Nigat Yasmin, Director, National Institute of Laser and Optronics, Professor Aziz Fatma Hasnain, Secretary General of National Center for Physics Education, Karachi, and Dr. Setsuko Kajima from Osaka University, Japan. Dean of Sciences, Professor Fardana Akram, Head of Department, Mrs. Ruxana Long, invited speakers, colleagues, and beloved students. I am pleased to welcome you all to the third international conference organized by Department of Physics, the Women University, Multan. Equal participation of men and women in scientific research drives innovation and strengthens the economy. It is believed that diversity in science can bring together people with unique background. There is a significant role of science in society for peace and development, and the need to engage the wider public in debates on emerging scientific issues is the need of the time. The need is to promote research partnership with equitable gender representation and underline the importance and relevance of science in our daily lives. Gender equality and parity in science is not only a fundamental human right, but a necessary foundation for a peaceful, prosperous, and sustainable world. Keeping women away from the revolutionary scientific field of 21st century will greatly hamper the development at global level. It is believed that untapped potential of women in areas such as science, technology, engineering, and mathematics may weaken the innovation potential of a science, of a society. Pakistan is a developing country that is striving to accelerate its economic growth and catch up with the pace of the fast-growing economy of the region. Women are more than 50% of Pakistan's total population. Despite constituting of almost half of the populations, women are an underutilized talent. For achieving national development, it is an economic necessity to utilize the talents of the women to the full at all levels of scientific and technological education, trainings, and employment. Realizing the widening gender gap and obscure status of women in socio-economic development, especially focusing on the gender dimension of science and technology, the Women University Multan has taken a lead to foster the women in scientific community and to improve the visibility of women scientists by organizing the international, national conferences, symposium, and workshops. Ladies and gentlemen, the women has special focus on capacity building. We help students to build up a solid body of well-trained specialists in science and technology who can pass on their expertise to future generations. Many of these scientists went on to play a key role in building capacity in physics in different departments. I expect that some of them are with us today. Ladies and gentlemen, conferences such as this provide a valuable opportunity for research scientists, industry specialists, and decision makers to share experiences. I am grateful to the many experts who have come to share their knowledge and experiences with us. I am grateful to the scientists who have contributed their knowledge and experiences to the development of science.
Assalamu alaikum. My name is Aliza Jamshed. I am from BS Physics 8th semester. Maybe Dr. Malika has some internet issues, so I will continue the speech. Conference Conferences such as this provide a valuable opportunity for research scientists, industry specialists, and decision makers to share experiences. I am grateful to the many experts who have come to share their knowledge. I also welcome the many representatives of the governments, industry associations, and NGOs who have joined us. Now, move forward and let's start the conference with the name of Allah, who is the most merciful and the most beneficial. Now, I am inviting Mehd Batul for the recitation of holy verses and praises of Muhammad, peace be upon him. Jazakallah, Subhanallah.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين صدق الله العلي العظيم.
Jazakallah, Subhanallah. Now I would like to invite our worthy and our ideal Vice Chancellor, Professor Uzma Qureshi, for welcome address and to chair the session next.
Our worthy Vice Chancellor will join us shortly, inshallah. Please continue.
Now I will call Mehek Rubab Naat, for Naat Rasul Makbul Sallallahu Alaihi Wasallam. Mehek Rubab.
يا محمد يا محمد يا محمد يا محمد बताता है खुद ये खुदाए मोहम्मद बनी है ये दुनिया बराए मोहम्मद बताता है खुद ये खुदाए मोहम्मद बनी है ये दुनिया बराए मोहम्मद शबे कद्र कुरान सामित کی صورت شب قدر قرآن صامت کی صورت مکمل ہوئی ہے ثنائے محمد بنی ہے یہ دنیا برائے محمد سر عرش معراج کی انتہا پہ سر عرش معراج کی انتہا پہ نہ پہنچا کوئی بھی سوائے محمد بنی ہے یہ دنیا برائے محمد بتاتا ہے خود یہ خدائے محمد بنی ہے یہ دنیا برائے محمد ہے پشت نبی پر بقائے نبوت ہے پشت نبی پر بقائے نبوت وہی آئی سرنا اٹھائے محمد بنی ہے یہ دنیا برائے محمد جبھی تو ہے حوروں کے چہرے درخشاں جبھی تو ہے حوروں کے چہرے درخشاں لگاتی ہیں وہ خاک پائے محمد بنی ہے یہ دنیا برائے محمد بتاتا ہے خود یہ خدائے محمد بنی ہے یہ دنیا برائے محمد یا محمد یا محمد یا محمد یا محمد.
Jazakallah. Ladies and gentlemen, the Women University Multan has a special focus on capacity building. We help students to build up a solid body of well-trained specialists in science and technology who can pass on their expertise to future generations. Many of these scientists went on to play a key role in building capacity in physics in different departments. I expect that some of them are with us today. Ladies and gentlemen, conferences such as this provides a valuable opportunity for research scientists, industry specialists, and decision makers to share their experiences. I am grateful to the many experts who have come to share their knowledge. I also welcome to many representatives of governments, industry, association, and NGOs who have joined us. Now I would like to invite our worthy Vice Chancellor and our ideal Professor Dr. Uzma Qureshi for welcome address and to chair the next section. Hello, ladies and gentlemen. The Worthy Vice Chancellor will shortly join us. Now I will like to call Professor Dr. Nigat Yasmin, Director NILOB, Islamabad. She will share a few words with us.
Director Nilo. I'm very thankful for the organizer to inviting me for this speech. Honorable Chief Guest Jodi Fawad Hussain, Federal Minister for Science and Technology, Pakistan, respected Professor Dr. Usma Qureshi, Vice Chancellor, Women University, Multan, respected Professor, teachers, faculty, and dear student, Assalamu alaikum and a very happy good morning. I express my heartfelt thanks to organizer of this online conference for inviting me as a speaker. It is my pleasure to share few humble thoughts with you people connecting women, concerning women's contribution in science, specifically physics. Dear friends, I need not to emphasize the importance and vitality of science. Modern life is entirely based on science and its technical offshoots. You just look around you and you will find one aspect of the science or the other around you. My present speech, being delivered from the hundreds of miles away, is enough to highlight the technical impact of the science. Just keenly look at it. Audio video recording, data transmission, internet, all are involved. Trace this communication revolution back in recent history and you will find it rooted to semiconductor physics with diode and transistors. These gadgets operate on the fundamental principles of the quantum theory. Therefore, technology, as you all know very well, is a fruit of science. Science itself, however, is something different and there is no tree of knowledge. Science is fundamentally based on human curiosity to understand the universe, and its collective endeavor is shared by both the genders, men and women, equally. This togetherness is in pursuance of the truth and reality is not new. Women have always been a part of it from antiquity to the present modern age. When the famous Greek philosopher Plato was teaching in the academy in 380 BC, the famous poetess and thinker Sappho was also training a school she used to teach in linguistics and poetry. Concerning science and mathematics, one is always reminded of the Hypatia, who was born in 350 AD in Alexandria. She was prominent thinker of the Neoplatonic school in Alexandria, where she taught philosophy, mathematics, and astronomy. Unfortunately, in 415 AD, she was murdered by a Christian mob, assuming that Hypatia was engaged in satanic practice, means science and philosophy. Spectra of the Hypatia fate is still haunting the female philosopher and the scientist, whether it is Madame Marie Curie or any of us. Thus, although women curiosity and creativity is enhanced, yet their contribution are tremendous, keeping in vastness of the work done by the women in science and mathematics. I will prefer to limit myself to only the subject of physics and mathematics, leaving biology and chemistry, where the women are sharing more knowledge in is and more prominent. This list is even quite long, and I just mention few groundbreaking discoveries made by women folk. For example, Marie Curie won the two Nobel Prizes in 1903 and 1911. Maria, in 1963, Nobel Prize in Physics for discovery of the nuclear shell structure. Donna Strickland, in 2018, Nobel Prize in the Physics for the high-intensity ultra-short optical pulses. Amy Noether, in 1918, Noether's theorem explaining the connection between the symmetry and conservation law. Cecilia in 1925 established that the hydrogen is the most common element in stars and thus the most abundant element in the universe. Merita in 1937, their work on the cosmic ray observations. In 1939, Leacier discovered the nuclear fission of the uranium. And in 1939, Margarita discovered the element of francium. Ruth, Marilyn, and Betty in 1945 programmed the first ever general purpose computer. Rosalind in 1952 identified the structure of the DNA through X-ray diffraction but unfortunately missed the Nobel Prize. The Chinese doctor, Dr. Wu, in 1956 showed that the parity could be violated in weak nuclear interaction that lead to the development of the standard model of the particle physics. Jacqueline in 1967 co-discovered the first radio pulsar, and in 1992 Mia, first African American women in space. Kathy in 2000 provided insight into the structure and history of the Milky Way galaxy. Line in 2001, experimental demonstration of the quantum phenomena of the slowing the light stopped the beam of light completely. Claudia in 2003, Project Galileo, a space exploration mission to the planet Jupiter. She worked in that project. In 2003, Deborah, she worked on the condensed pair of the fermion atoms. In 2011, Chinese Dr. Ma discovered two of the largest black holes ever observed. In 2018, Jonah she worked on the evolution of the cosmos and the fluctuation that seeded the formation of galaxy. Karen in 2019 worked on the particle physics and gauge theories. This is the list that includes only the most important work done by the women in the field of physics. Apart from this, there are a lot of ladies working in mathematics and mathematical physics. Maryam Mezahani at Iran received a field medal in mathematics, equivalent to the Nobel Prize, on her work on the dynamics and the geometry of the Riemann surface and their moduli space. Unfortunately, she died of cancer at an early stage. Nationally, when I was a student, the situation was not that bright for the females. At the Quaid-e-Azam University, Islamabad, we have only the two female professors in the physics department. Other universities were even less in score. However, now the things have changed for better. There is a lot of female faculty in all the universities and the research institute. For example, we at the National Institute of Laser and Optronics have more than 10 lady scientists and the engineer engaged in the forefront research. In general, as I said earlier, science is based on curiosity and free thinking. These traits are not linked with any gender and history demonstrated that the women have the potential for creative achievement. Dear students, curiosity and the free thinking are prerequisite for the physics. Never accept anyone as authority. There is no authority in science. Raise questions and come out of the dogmatic slumbers. Once Einstein said, the important thing is not to stop questioning. Curiosity has its own reason for existing. Universe is a beautiful riddle. Ponder over it and look at every existing theory or ideology, especially you have ability to demolish idols and to create new knowledge. I end my talk with a poem written by Nadia Amber Lodi, the title of Aurat. तुम मेरी आवाज़ दबा नहीं सकते, मेरे लिखे हुए अल्फाज मिटा नहीं सकते, नहीं रख सकते मुझे पाबंदे सलासल, तुम मेरी आवाज़ दबा नहीं सकोगे, नाखून शौक से रोज़ाना कुरे दूंगी मैं एक नई दीवार, ताकत परवास से मुसख्खर करूंगी नए जहान, पर काट कर मेरे पिंजरे में मुक़य्यद नहीं रख सकते तुम, ख्वाब नोच कर मेरी आंखें तस्कीर नहीं कर सकते तुम। औरत हूँ मैं, साहिब अकल व फ़हम हूँ, बहता हुआ पानी हूँ, हर सदी की मैं ही कहानी हूँ। थैंक यू।
Thank you so much, Ma'am Nikat Yasmin. Now, I would like to invite Professor Fatma Hasnain, Secretary General of Center for Physics Education, to share us with her precious words. Ma'am Fatma Aziz.
Ji Aziz Fatma Hasnain.
Yes, ma'am. Yes, ma'am.
Thank you, Malika Rani. Honorable Chief Guest, Mr. Fawad Chaudhary, Minister for Science and Technology, and Vice Chancellor, Women University of Multan, Dr. Malika Rani, Dr. Uzma Qureshi, Malika Rani, the organizer, head and Department of Physics, and honorable guest speaker, Dr. Tajima, Dr. Asghari Maqsood, Dr. Anisa Kamar, Dr. Nigat Yasmin, distinguished guest and women physicist of Pakistan. Assalamu alaikum. My heartiest congratulations to Dr. Malika Rani and Dr. Uzma Qureshi for organizing first ever in Pakistan an international e-conference on women in physics. This e-conference is the outcome of courageous efforts of Dr. Malika Rani and Dr. Uzma Qureshi. Congratulations to you. I feel honored speaking on this August occasion. Mr. Fawad Chaudhary and distinguished participants, we all know that we live in a country where access to education is ignored by the society. According to UNDP 2018 report, there are 43,91,144 primary schools and 22.5 million children are out of school. Also, 32% primary school going age girls are out of school and 59% girls are not enrolled in secondary school as compared to boys. The access to higher education among girls is very minimal. We have a society where girls are not allowed to go to school. Our society is full of gender inequalities. A country cannot be progressed by having gender disparities. I know how difficult for our young girls to come out of home. The environment of our social structure is not conducive for girls. In these circumstances, when we talk about women in physics, sounds strange to everyone, but there are some realities to address. Dr. Judy France, former chairperson, American Physical Society, identified and realized that young women in physics had difficulties in building their career in physics. In 2002, Dr. Judy France had organized an international conference on women in physics in order to provide a platform for women in physics so that the scientific work of women be highlighted. The international conference was marked as a milestone for women in physics, and the world has witnessed that the women in physics started playing key role in the development of physics. After 2002 conference, an international commission on women in physics was formed under the umbrella of IOPAP, International Union of Pure and Applied Physics. Since then, every country has a working group on women in physics in the universities. These working groups are supported by IOPA for the research work in physics. But these grants come under a condition that each country should be the member of IOPA. Pakistan, the Working Group on Women in Physics in Pakistan efforted hard to the membership of IOPA. Dr. Anisa Kamar had been the instrumental in making in reviving the membership IOPA. Pakistan had been the member of IOPA for 2 years, 2015 and 16, and now its membership has been removed because of the non-payment of annual fee. The membership of IOPA is beneficial to a country for continuing scientific research work. Here I request Mr. Fawad Chaudhry to renew IOPAP membership by paying $2,000 annually. I request Ministry of Science and Technology to keep continue the fee payment annually. I hope Mr. Fawad Chaudhry, who have a vision of the promotion of science, will consider the fee payment for the promotion of physics in the country. At the end, once again, I congratulate Dr. Uzma Qureshi for having a vision of promotion of physics among girls, and also to Dr. Malika Rani, a courageous and aspiring women physicist and has inspiration for young girls. I hope the physics under the leadership of Malika Rani will shine in research and develop. The young girls will continue higher education in physics and its research. We all know that physics is the basis of technology. The development of physics is the key to progress of a country. Thank you very much. Thanks again.
Thank you so much, ma'am. I warmly welcome to our Honorable Chief Guest, Chaudhry Fawad Hussain, Federal Minister for Science and Technology. Sir, thank you so much for joining us.
Ji, Assalamu alaikum. Go ahead.
Walaikum Assalam. Sir, Women University Multan has a special focus on capacity building. We help students to build up a solid body of well-trained specialists in science and technology who can pass on their expertise to future generations. Many of these students went to play a key role in building capacity in different departments. Sir, we have organized two conferences. There were also international conferences. This is our third international conference, and we are working in different subjects and different projects also. So we welcome you to our third international conference.
तो कितने participants हैं और it's a faculty that is in the conference or the students?
So students and faculty and different scientists from national and internationals are participating in our conference.
Awesome.
Ji, Assalamualaikum ji, this is Assalamualaikum. This is Dr. Usman Qureshi, Vice Chancellor of the Women University Multan. People couldn't hear me. Sir, thank you very much. I'm sorry I had to I had joined, but my team didn't know. Thank you very much for your time. We are very deeply encouraged because of your presence. I met you in Islamabad and requested you to come and visit our university, but this is really very encouraging on your part to participate in this conference. I welcome you formally, sir, and I welcome all the participants. There are about 5-6 countries which are participating, and it will be sort of organized for another time in October, where we hope that we'll be able to welcome them to Pakistan. So thank you again, and we are waiting for your kind words.
So thank you very much, Dr. Uzma, and the faculty and the students and all the participants here. So I'm indeed honored to be a part of such a distinguished gathering. बस मैं तो इतना कहूँगा कि पहले डॉक्टर उस्मा जो हैं ज़ाहिर है वो तो उनसे मेरी मुलाकात भी हुई है और आई एम ऑलवेज वेरी I would say that very keen that for the women participation in science and technology, and I'm very happy that this conference uh, to look at the uh, future of women in physics is being held by this university. देखिए दुनिया में पूरी तरह एक तो मैं ये कहूँगा जो तमाम स्टूडेंट स्पेशली जो इस कॉन्फ्रेंस में हैं अब ये जब से इंटरनेट आया है तो ये क्वालिटी का इशू जो है एजुकेशन में वो नहीं रहा है if you can speak or read a bit of English and you can use internet तो फिर sky is the limit. आपको अगर आप पिछली कहानियां जाके पढ़े कि जैसे लोगों ने जो जमाने में जो ये तरक्की जो आज इंसान देख रहा है जिसमें फिजिक्स का बहुत ही बड़ा किरदार है वो कैसे हासिल हुई और लोगों ने कितनी मेहनत की इस मुकाम को पाने के लिए. अगर आप मारी क्यूरी की कहानी पढ़ें, अगर आप जो बाकी आपकी जो फिजिक्स की जो बड़े बड़े जो नाम रहे हैं उनकी अगर आप कहानियां पढ़ें तो आपको अंदाजा होगा कि कितनी उन्होंने गुर्बत में, कितनी उन्होंने बैकवर्डनेस में ये तरक्की हासिल की. लाइव मिटनर हैं, आपकी मारी क्यूरी हैं, उसके बाद इवन हमारे अपने जो डॉक्टर अब्दुल सलाम हैं जिन्होंने अगर आप उनकी कहानी पढ़ें कैसे एक गाँव से बिल्कुल उठ के उन्होंने पूरी दुनिया को बदल के रख दिया. सो दीज आर द पीपल हु गिव यू होप फॉर द फ्यूचर. ये वो लोग हैं जिन्होंने दुनिया की तारीख को लिखा है, चाहे वो कोई भी तारीख हो, चाहे वो सियासी तारीख हो, हमारी मुआशरती तारीख हो या फिर हमारी साइंस की तारीख हो. So first thing is that I'm really happy that you have so many women students in physics here also in your university and elsewhere, and in Pakistan actually girls are doing fairly well जब हम उनका कंपैरिजन करते हैं बॉयज के साथ, क्योंकि पूरी दुनिया में ही फिजिक्स में स्पेशली जो खवातीन की पार्टिसिपेशन है वो एक प्रॉब्लम है. फॉर एग्जांपल इवन यूके में 2018 में जो उन्होंने सर्वे किया तो उनको एहसास हुआ कि जो खवातीन की तादाद है मर्दों के मुकाबले में वो बहुत ही कम है. और इंटरेस्टिंगली ए लेवल्स तक यानी तकरीबन 16 साल की एज तक खवातीन की तादाद एक्चुअली लड़कों से ज़्यादा थी जो कि फिजिक्स में या साइंस में थे, लेकिन 16 साल के बाद वो तादाद अचानक जो है वो कम हो गई. उसकी वजह ये है कि एक ओवरऑल इन्वायरमेंट नहीं रहा खवातीन के लिए कि वो साइंटिस्ट के तौर के ऊपर जो है या फिजिक्स के तौर के ऊपर फिजिसिस्ट के तौर के ऊपर जो है वो आगे बढ़े. बट अगर आप एक ओवरऑल सिचुएशन में देखेंगे तो ये नंबर दुनिया में भी कम है और पाकिस्तान में इस नंबर के कम होने का जाहिर है कि एक जवाब भी बनता है. जब पूरी दुनिया में कम है पाकिस्तान के अंदर भी कम है, लेकिन पाकिस्तान के अंदर मैं थोड़ा सा आपको ये बताना चाहता हूँ कि वी स्टार्टेड एज अ वेरी रोबस्ट कंट्री इन साइंस एंड टेक्नोलॉजी. जब पाकिस्तान 1947 में आज़ाद हुआ तो 5 साल के बाद ही तकरीबन 1952 में हमने वेस्ट पाकिस्तान लेबॉर्ट्रीज क्रिएट की. वेस्ट पाकिस्तान लेबॉर्ट्रीज जो थी जो बाद में PCSIR के नाम से जानी जाती है, दैट वाज probably one of the most modern scientific institution of third world at that time. Actually मुस्लिम वर्ल्ड को तो भूल ही जाए, थर्ड वर्ल्ड में भी इस तरह का कोई इंस्टीट्यूशन जो है वो नहीं था. PCSIR जो है फिर इसने बेसिस दी जो 1960s की हमारी इंडस्ट्रियल रेवोल्यूशन आया उसका. प्रोफेसर सलीम उर रहमान साहब जैसे बड़े नाम जो हिंदुस्तान से आए उन्होंने PCSIR को सेट किया और उसको उन्होंने जो है वो बनाया. और जो 60s की हमारी रेवोल्यूशन आया, इंडस्ट्रियल रेवोल्यूशन आया, वो लिंकेज था PCSIR का और इंडस्ट्री का, दैट ब्रॉट दैट रेवोल्यूशन. सो 60s के बाद हमने देखिए 1959 में जब डॉक्टर अब्दुल सलाम अमेरिका गए तो 1960 में आके हमने अपना स्पेस प्रोग्राम शुरू किया. आज जब हम ये बात करते हैं कि पाकिस्तान इस साल अपना स्पेस मिशन भेजेगा या अगले साल अपना स्पेस मिशन भेजेगा تو لوگوں کو تو یقین ہی نہیں آتا کہ پاکستان بھی یہ کر سکتا ہے. بٹ فیکٹ آف دا میٹر از دیٹ ہم نے 1960 میں اپنا اسپیس پروگرام شروع کیا تھا, جبکہ ایشیا میں یو ایس ایس آر, سوویت یونین تھا, اور اس کے بعد پاکستان تھا. امریکہ, یہ جو چائنا ہے اور انڈیا ہے ایشیا میں, یہ تو کسی قطار میں ہی نہیں تھے جب ہم نے اپنا اسپیس پروگرام شروع کیا. اور 1963 میں جب ہم نے اپنا پہلا راکٹ رہبر خلا میں بھیجا تھا, تو اس وقت پاکستان واز جسٹ سیکنڈ کنٹری ان ایشیا آفٹر سوویت یونین جس نے یہ کارنامہ انجام دیا. سو یہ ہمارا جو تھا وہ آپ سمجھیے آغاز تھا. اسی طریقے سے آپ ایک اور اگر آپ دیکھیں کہ جو PCRWR ہے, پاکستان کونسل فار ریسرچ اینڈ واٹر ریسورسز, یہ ہم نے اس کی بنیاد 1964 میں رکھی, 1964 1964 میں جو ہم نے PCRWR کی بنیاد رکھی اور پانی کے اوپر ریسرچ کا ادارہ بنایا, تو ایون فرسٹ ورلڈ میں بھی کوئی نہیں سوچ سکتا تھا کہ پانی بھی کوئی چیز ہوگی جس کے اوپر ریسرچ کرنی پڑے گی. بٹ وی ڈیڈ دیٹ, اینڈ دس واز دا کائنڈ آف دا ویژن دیٹ پاکستانی جو ہمارے جو فور فادرس تھے یا ہمارے جو بانیان تھے ان کا تھا. سو یہ ہمارا آغاز تھا. 1952 سے لے کے 1964 تک پاکستان کا ایک گولڈن پیریڈ رہا سائنس اور ٹیکنالوجی میں. 1971 میں جب سقوط ڈھاکہ ہوا اور اس کے بعد جب افغانستان ہمارے ساتھ ایک پولیٹیکل آیا, تو یہاں پہ میں جو سائنٹسٹ ہیں ان سے میں یہ بھی کہنا چاہوں گا کہ پلیز ڈو آلسو ریڈ آپ کی جو سوشل اور جو آپ کا ایک فلسفی اور پالیٹکس کے اوپر بھی پڑھا کریں, سو دیٹ آپ کو اندازہ ہو کہ کس طرح سے, کیونکہ الٹیمیٹلی اٹس the politics that affects everything in a society. So how that affected Pakistan جب ہماری افغانستان کی ساتھ, افغانستان میں جو لڑائی شروع ہوئی اور اس سے پہلے جب سقوط ڈھاکہ ہوا, ہم نے کیا کیا کہ اپنی تمام جو سول R&D تھی, سول سائنسز تھیں, اس کو ہم نے شفٹ کر دیا سیکیورٹی کے اوپر اور فوج کے اوپر. یہاں پہ ہم نے ایک بڑی غلطی یہ کی کہ ہم سے, جیسے اسرائیل نے کیا, جیسے چائنا نے کیا, جیسے امریکہ نے کیا, انہوں نے اپنی سول ریسرچ اینڈ ڈیولپمنٹ کو اور ملٹری R&D کو ساتھ ساتھ چلایا. فار ایگزامپل, اگر اب جب آپ آئی فون اٹھا کے دیکھتے ہیں تو آپ کو احساس ہوگا کہ اس کی 60% ایپس ایکچولی ڈیفینس ایپس ہیں. فار ایگزامپل, اگر آپ نے GPS جو ہے, اب ہم دیکھتے ہیں عام ہے کہ ہم گوگل میپ میں ڈالتے ہیں اور اپنی منزل پہ پہنچتے ہیں, GPS یوز کرتے ہیں, ایکچولی یہ ڈیفینس ایپس تھی. اسی طریقے سے جو ہمارا کیمرہ ہے جس میں تھرمل ٹیکنالوجی یوز ہوتی ہے, یہ ڈیفینس ایپ تھی. سو یہ تمام چیزیں ڈیفینس سے سول میں آئیں. انفارچونیٹلی ہم نے 71 کے بعد اپنا جو ہمارا ایک سمجھیے کہ جو ہمارا ایک فوکس تھا وہ ہمارا رہا صرف ڈیفینس کے اوپر, سیکیورٹی کے اوپر, لیکن ہم نے اس کو یوز نہیں کیا سول سائڈ کے اوپر. لہٰذا آج ہم پاکستان میں 70% جو الیکٹرانکس ہیں JF تھنڈر کی, وہ ہم خود بناتے ہیں. And Pakistan is probably the only 6th or 7th country in the world that manufactures its own fighter plane. But unfortunately ہم اپنا ٹی وی نہیں بنا سکے, ہم اپنا موبائل نہیں بنا سکے, لیکن ہم JF تھنڈر کے الیکٹرانکس جو ہیں وہ بناتے ہیں. لائک وائز ہم الخالد ٹینک پاکستان کے اندر ہم بناتے ہیں, لیکن ہم اپنی کار نہیں بنا سکے کیونکہ ہم نے اپنی جو سول ملٹری انٹرفیس تھا وہ کریٹ نہیں کیا. اب الحمدللہ جب میں نے منسٹری سنبھالی تقریباً 12-13 مہینے پہلے, تو I have tried to bring radical changes in this ministry, science and technology. We have created this civil military interface, and from this year جو projects ہیں سارے civil military کے وہ اکٹھے چلیں گے. لائک وائز ایک اور بڑی غلطی جو ہم سے ہوئی وہ یہ ہوئی کہ 80s میں جب پاکستان افغانستان کے اندر تھا تو پوری دنیا پاکستان کے پیچھے کھڑی تھی, اور اس وقت ہمارا جو باقی کاموں میں سے ایک کام ہمارا یہ تھا اس وقت کی لیڈرشپ کا کہ ہم جو دنیا کے بڑے ریکگنائزڈ انسٹیٹیوشنز ہیں, MIT ہے, ییل ہے, ہارورڈ ہے, کیمبرج ہے, آکسفورڈ ہے, ہم ان کے کیمپسز کو پاکستان لے کر کے آتے. اگر ہم نے 80s میں یہ کیمپسز پاکستان میں بنائے ہوتے تو یو کین جسٹ امیجن آج ہمارا جو ہیومن ریسورس لیول ہے, HR ہمارا جو ہے وہ کہاں پر ہوتا. بٹ انفارچونیٹلی ہم نے اس کے اوپر فوکس نہیں کیا اور ہم جو ہے وہ ان کیمپسز کو پاکستان میں لانے میں ناکام ہوئے. ہندوستان نے دوسری طرف جب ان کے تعلقات امریکہ سے تھوڑے سے بھی ٹھیک ہوئے تو پہلا کام انہوں نے یہ کیا کہ MIT کو کہا کہ آپ انڈین انسٹیٹیوٹ آف ٹیکنالوجی بنا کے دیں, اور پہلا جو انڈین انسٹیٹیوٹ آف ٹیکنالوجی ہے وہ امریکہ نے بھارت کو بنا کے دیا, اور اب جو انڈین انسٹیٹیوٹ آف ٹیکنالوجی ہے اس کا جو میرٹ ہے وہ MIT USA سے بھی زیادہ ہے. So this is the kind of mistakes that we made and this is the kind of past that we have. So اب سوال یہ ہے کہ یہاں سے ہم نے آگے کیسے چلنا ہے. دو ایریاز ہیں, ظاہر ہے اپلائیڈ سائنسز ہیں اور سبسٹینٹیو سائنسز ہیں یا بیسک سائنسز ہیں. تو یونیورسٹیز میں پاکستان میں ایکچولی دیکھیے میری نظر میں تو کیا ہونا چاہیے, میری نظر میں تو یہ ہونا چاہیے, ایک تو ہم پاکستان کے اندر دو بڑے پرابلمز ہیں. ایک پرابلم یہ ہے کہ ہمارے پاس پیسے نہیں ہوتے, اور دوسرا پرابلم ہے ہم پیسے ضائع بہت کرتے ہیں. سو ہمارا بنیادی طور کے اوپر جو ہمارے پرابلمز ہیں وہ ان دونوں ایریاز میں ہیں. ہماری جو فار ایگزامپل جو یونیورسٹیز ہیں ان کو پرائرٹائز کرنا چاہیے ایکچولی کہ ہمیں آئندہ فیوچر میں کیا HR چاہیے, ہمارا ہیومن ریسورس ہمیں چاہیے کیا. یہ کام انڈسٹریز اور کامرس کو گائیڈ کرنا چاہیے. انڈسٹریز اینڈ کامرس شوڈ سٹ ٹوگیدر اینڈ سی کہ پاکستان کی امپورٹس کیا ہیں, ایکسپورٹس کا ہمارا کیا مارجنز ہیں, اور پھر اس کے مطابق ہمیں اپنی سبسڈیز ڈیسائیڈ کرنی چاہیے. کہ فار ایگزامپل اگر میں انٹرنیشنل ریلیشنز میں ماسٹرز کرنا چاہتا ہوں تو میں اپنے پورے پیسے دوں اور انٹرنیشنل ریلیشنز میں ماسٹرز کروں. لیکن اگر حکومت کو یا ریاست کو, ملک کو ضرورت ہے فزسسٹ کی, یا ضرورت ہے کیمیکل انجینئرز کی, یا انجینئر میکینیکل انجینئرز کی ضرورت ہے, تو وہ ڈگریز کو سبسیڈائز کیا جائے تاکہ لوگ اس میں ہمارے پاس جو ہماری متعلقہ سمجھیے کہ محکمے ہیں یا جو ہمیں ضرورت ہے, university should produce that kind of HR that state needs. So in my view this is I would say that whole structural reform that we must look for, and this is the something that should happen. Secondly ہماری جو اکیڈیمیا ہے, دیکھیں دنیا جو ہے نا وہ لنکیجز سے آگے چلتی ہے, اکیلا کچھ جو ہے وہ نہیں ہو سکتا. انفارچونیٹلی پاکستان میں ہمارا, جس طرح میں آپ کو بتا رہا تھا کہ ہم نے اپنا اسپیس پروگرام 61 میں شروع کیا, لیکن ہم آج کہاں کھڑے ہیں, اور ہندوستان آج کہاں کھڑا ہے, چائنا کہاں کھڑا ہے. اس کی وجہ یہ ہے کہ ہم نے اپنے جو لنکیج تھے انٹرنیشنل لنکیجز یا تو اسٹیبلش نہیں کیے یا اس کو یوز نہیں کیا. آج سرن کا بھی پاکستان جو ہے وہ اس طرح کا ممبر نہیں ہے, اور اسی طرح سے ہمارا جو انسٹیٹیوٹ آف فزکس ہے اسلام آباد میں, یا پھر ہمارا اسپارکو ہے, یا پھر ہمارے جو ادارے ہیں یا سائنٹسٹ ہیں, پاکستان میں بہت ہمارا جو لنکیج ہے, انٹرنیشنل لنکیج ہے, وہ بہت کمزور ہے. سو آئی وڈ انکریج یونیورسٹی آف ملتان اینڈ ادر یونیورسٹیز جو بھی ہیں, آپ اپنے انٹرنیشنل لنکیجز ڈیولپ کرنے کی کوشش کریں. ایک تو مجھے خیر یہ کبھی سمجھ نہیں آتا کہ یونیورسٹیز جو ہیں ان کو فورن آفس کے تھرو کیوں جانا پڑتا ہے ایون ایک سمپل سا MOU سائن کرنے. تو آئی ایم ٹرائنگ مائی بیسٹ کہ یونیورسٹیز جو ہیں ان کو یہ کیا جائے کہ وہ اپنے انڈیپینڈنٹ ریلیشن شپ بنا سکیں. سیکنڈلی اٹس بین 2 years آئی ایم ٹرائنگ مائی بیسٹ کہ یونیورسٹی شوڈ بی الاؤڈ ٹو ڈو دیئر اون بزنسز, کیونکہ یونیورسٹیز کے اندر جو ریسرچ ہوتی ہے اس کو فار ایگزامپل ہارورڈ جو ہے وہ 13% کا اونر ہے فیس بک میں. اسی طرح سے جو ہمارا اسٹینفرڈ ہے وہ 27% اون کرتا ہے یہ یاہو کو. اب جب یہ یونیورسٹیز کو جب تک یہ پیسہ اپنا خود نہیں بنائیں گی, پیسہ اپنا خود نہیں کمائیں گی, یہ اپنی چیزیں اسٹیبلش نہیں کر سکیں گی. سو وی ہیو ٹو الاؤ یونیورسٹیز کہ وہ اپنے ریسرچ کو, اپنے اکیڈیمیا کو انڈسٹری سے جوڑ سکیں, اور پھر ٹاپ ریسرچ انسٹیٹیوشن سے جوڑ سکیں, اور ایک لنکیج ہمارا کریٹ ہو. سو آئی وڈ انکریج یونیورسٹیز کہ آپ اپنے جو HEC ہے, اور ایکچولی یو کین یوز ایس آلسو بیکاز سائنس اینڈ ٹیکنالوجی کا ایک فائدہ یہ ہے کہ یہ ڈیوالوڈ سبجیکٹ, یہ ڈیوالوڈ منسٹری نہیں ہے. سو جہاں پہ آپ کو ایجوکیشن میں بہت روٹس لینے پڑتے ہیں, اپنے لوکل جو آپ کے جو ہیں ان کے پاس جانا پڑتا ہے, جو آپ کا جو سائنس ڈپارٹمنٹس ہیں, they can actually directly approach Ministry of Science and Technology for any help that you may need in that regard. So my request will be that آپ بہت سارے جو آپ لوگوں کو پرائرٹائز کیا کرنا چاہیے. نمبر 1, آپ لوگوں کو پرائرٹائز کرنا چاہیے کہ ہم اگلے 5 سالوں میں 3, اور پہلی بات تو یہ ہے کہ جو پلاننگ ہے, جو میری اپنا جو میرا پوائنٹ آف ویو ہے, اب وہ زمانہ نہیں رہا کہ آپ 30 سال کی پلاننگ کر سکیں, کیونکہ ٹیکنالوجی اتنی زیادہ ہے. کوئی ایلان مسک آ جاتا ہے, کوئی بل گیٹس آ جاتا ہے, کوئی زکربرگ آ جاتا ہے, وہ دنیا کو اوپر سے نیچے کر دیتا ہے. سو یہ 22 سال کے جو لڑکے لڑکیاں ہیں, انہوں نے دنیا کو شیپ اپ کیا ہے, and they will continue doing that, and they will continue doing so because جو ٹیکنالوجی ہے وہ اب اتنی زیادہ اور آگے چلی گئی ہے that it gives new avenues to explore, and it gives new I would say that new landmarks to be achieved. So اس لیے یہ لمبی پلاننگز نہیں ہو سکتی. So you should plan for 5 years or maximum 7 years, not more than that. So پہلی بات تو یہ 5 سے 7 سال کی آپ کی پلاننگ ہونی چاہیے, اور 2 سے 3 سال میں آپ کی ایگزیکیوشنز ہونی چاہیے. سو پہلا تو میری نظر میں یہ ہے. سیکنڈ یہ ہے کہ پھر آپ یہ بنائیے کہ ہمارے کون سے سبجیکٹس میں کون سے ادارے ہیں دنیا میں جن کے ساتھ ہمیں انٹرنیشنل لنکیج اسٹیبلش کرنی چاہیے. بیکاز انلیس آپ کو جو ٹاپ یونیورسٹیز ہیں یا جو بڑے لوگ ہیں سائنس ورلڈ کے, ان کے ساتھ ایک انٹریکشنز نہیں ہوں گے, تو ہمیں پتہ نہیں چلے گا کہ ہم ڈائریکشن ہماری صحیح ہے اور وہ لوگ کدھر جا رہے ہیں. بیکاز یو ہیو ٹو فالو آئیکنز, یو ہیو ٹو فالو اپنی منزل کو, جو ہے وہ راستہ بھی چاہیے ہوتا ہے منزل تک جانے کے لیے. سو ایک تو میں یہ کہوں گا کہ یونیورسٹیز must establish their international linkages so that آپ کو پتا ہو. پھر اپنی جو یونیورسٹیز جہاں پہ ہیں, لوکل انوائرمنٹ کو دیکھتے ہوئے لوکل انڈسٹری کے لیے آپ کو ضرور جو ہے وہ ایک ہیلپ آؤٹ کرنا چاہیے, اور دیکھنا چاہیے کہ لوکل انڈسٹری میں کس قسم کے جو HR ہے اس کی ضرورت ہے, اور کس قسم کی ہیومن ریسورس جو ہے وہ الٹیمیٹلی آ جائے گا. تھرڈ از that universities now must focus on entrepreneurship. پاکستان 22 کروڑ کی آبادی کا ملک ہے. یہاں پہ جو اسٹوڈنٹ باہر نکلتا ہے, ہم جو کوشش کر رہے ہوتے ہیں یونیورسٹیز میں, زیادہ تر اسٹوڈنٹ جو ہیں وہ نوکری کے لیے پڑھ رہے ہوتے ہیں. ہمیں ان کی ڈائریکشن کو انٹرپرینورشپ کی طرف لانا ہوگا. Unless we don't bring the I would say the environment and the culture in which entrepreneurship can grow, پاکستان کا مسئلے کبھی حل نہیں ہوں گے. پاکستان میں پاکستان انجینئرنگ کونسل کو بھی یہ کہتا ہوں, باقی اداروں کو بھی کہتا ہوں کہ آپ کا تمام فوکس یہ ہے کہ گورنمنٹ جابز جو ہیں وہ اویلیبل ہوں. گورنمنٹ جابز اویلیبل ہو ہی نہیں سکتی کیونکہ جو نئی ڈیولپمنٹس ہیں دنیا میں, گورنمنٹ چھوٹی ہو رہی ہے اور پرائیویٹ سیکٹر جو ہے وہ بڑا ہو رہا ہے. اور ہمارا فوکس بھی یہی ہونا چاہیے کہ ہم جو اسٹوڈنٹس ہیں ان کو پرائیویٹ سیکٹر کے لیے تیار کریں. اور اسپیشلی میں سمجھتا ہوں کہ جو سائنس ہے اس میں تو بالکل, اور اسپیشلی جو خواتین ہیں ان کے لیے تو انٹرپرینورشپ از ایکچولی more I would say viable and more it's easier than job to actually establish your own entrepreneurship. So ہمیں فوکس یہ کرنا چاہیے کہ ہم خواتین کو کیسے انٹرپرینورشپ کی طرف لائیں, اوور آل سائنٹسٹ ہمارے جو ہے وہ کیسے اس کی طرف آئیں. اینڈ لاسٹلی کہ ہمیں اپنی لیبارٹریز کو ہم کیسے تگڑا کریں, ہم اپنی R&D کو کیسے تگڑا کریں. اس کے بھی ہمیں ایک تو ظاہر ہے کہ ہمیں ایک انٹرنیشنل لنکیج چاہیے سو دیٹ کہ ہمیں لیبارٹریز میں کام ملے. اور پھر آپ کو جب انٹرنیشنل لنکیج ہوگا تو ہمیں انٹرنیشنل ریسرچ پروجیکٹس میں ہماری شمولیت ضروری ہے. اس سے پھر ایک ایکسپوجر بھی ڈفرینٹ ہوگا, اور ہمارے جو لوگ ہیں, ہمارے جو سائنٹسٹ ہیں وہ زیادہ اس سے حاصل بھی کر سکیں گے. اس کے علاوہ میں اس کے اوپر I'm really convinced ہمیں جو ایجوکیشن کا کوالٹی آف ایجوکیشن ہے وہ اب ایشو نہیں رہا ہے. اگر آپ کے پاس انٹرنیٹ ہے, آپ کے پاس اور آپ انگریزی آپ کو پڑھ سکتے ہیں, آپ کے لیے کوئی پرابلم نہیں ہے इंटरनेट के ऊपर दुनिया भर की जो आप समझिए किताबें अवेलेबल हैं, दुनिया भर की रिसर्चेज अवेलेबल हैं। सो ये तो एक शौक की बात है कि किसका कितना शौक है, कौन कितनी अपॉर्चुनिटी देखता है, कौन कैसे उसको एक्सप्लोर कर सकता है। सो मुझे बड़ी खुशी है, इस साल पाकिस्तान ने एक बहुत बड़ा रिवाइवल हुआ हमारे यहाँ साइंस एंड टेक्नोलॉजी का। कोविड में केस पाकिस्तान में आया था, तो 26 फरवरी को पहला कोविड केस आया था। हम कुछ भी अपना नहीं बना रहे थे, हमें हर चीज़ हम बाहर से इंपोर्ट कर रहे थे, चाहे वो गाउन हो, चाहे वो गॉगल्स हो, चाहे वो फेस शील्ड्स हो, चाहे वो वेंटिलेटर्स हो, चाहे वो मेडिकल इक्विपमेंट हो। आज जस्ट आफ्टर फ्यू मंथ्स ऑफ दैट, जो हमारे ऊपर बला नाज़िल हुई कोरोना की, उसके बाद आज एटलीस्ट पाकिस्तान इज नॉट ओनली हम सेल्फ सफिशिएंट हैं, हम अपनी सारी चीज़ें खुद बना रहे हैं, रादर बट वी आर वन ऑफ द मेजर एक्सपोर्टर्स इन ऑल द पीपीज एंड सैनिटाइजर्स। एंड अल्हम्दुलिल्लाह हमारा एक फैक्ट्री जो वेंटिलेटर्स की थी वो 2 महीने से चालू है। एनआरटीसी में 250 वेंटिलेटर महीने का हम अपना बना रहे हैं। अगले हफ्ते इंशाल्लाह प्राइवेट सेक्टर का जो पहली कंपनी है एलिसन्स, वो अपना वेंटिलेटर बनाना शुरू कर देगी। तो वी विल बी इन द, आप समझिए कि इन अमंग दोज फ्यू कंट्रीज जो वेंटिलेटर्स एक्सपोर्ट कर रहे हो। So you can imagine the kind of revival that we have seen in the science and technology. And thank you very much for having me here. And um, I'm very, I would say that honored to be here in this prestigious gathering. And I wish you all the best. And I wish Multan University and the Vice Chancellor Saiba, aapko badi mubarak ho. I wish all the success of this conference. I wish the students all the best, and all the the faculty members and the people who participated in this conference. Thank you very much for having me, and you are more than welcome to visit me in my office in Islamabad, and certainly I will avail the opportunity to visit this university as soon as this corona thing goes on. Thank you very much for having me.
Thank you very much, sir. So it has really been a great, what should I say, I can't express my gratitude enough for your presence here today, because our students need encouragement. And the 5 very important aspects which were told us about today is our focus as well. We are looking at international linkages, we focus on entrepreneurship, we are looking at the local job market also. We make sure that we are trying, while the resources are very limited, एक थोड़े ज़राए हैं, लेकिन उसके बावजूद we're making sure that our labs are coming up to the mark and they are as per need, not of just the students and their research, but otherwise also we will be reaching out globally. And best thing which you said today is that we need to have this private sector model for our public sector universities. We need to be able to generate our own funds and rely a lot less on the government. Thank you, sir. Your presence has been not just a source of encouragement, but it has given us a vision to move forward. Thank you, sir. I would ask the organizers to let us know what we should do now next. If the minister is still on, we can carry on with the discussion, or we can take a break and start all over again. Dr. Malika, what is your now?
Ma'am, thank you so much. Ma'am, thank you so much. Now, in this era where men prevailed in every field, women are also giving their best to every field. I am very glad that our female students give their best to their research and made very useful projects which are need of this era. I call the students of MSc and BS, please come and give short introduction about their projects.
Mr.
Dr. Malika, Rani, and Hafiza, Batul, Yasmin, Zara, and Ikra Shahzadi. We have synthesized 2 compounds, copper chromide spinel nanoparticles and cobalt chromide spinel nanoparticles. Copper chromide is synthesized for clean energy production, but this compound has further many applications like commercial application, hydrogen application, removal of aqueous of organic waste, drugs and agrochemicals, sensor and electrodes. But we are working on two main applications, which one is clean energy production and second one is electrode and sensors. And we have also synthesized cobalt chromite, which have many applications like catalytic combustion, transformer core, drugs delivery, gas sensors, and it is also used as in pigment and preparation of film. But we are working on two applications like catalytic combustions and gas sensors. These compounds have doped many other compounds like CD, ND, Mg, Sr, and CO. And we have characterized these two compounds for further many applications like UV analysis, Raman spectroscopy, photoluminescence, SEM, EDS, and XRD. From these characterization, we have obtained very good results. And from EDS, it was clearly showed that we have succeeded to synthesize these two nanoparticles, and we are working more and more on these two applications. And thank you so much for your attention.
Assalamu alaikum. My name is Eliza Jamshed. My roll number is 2. I am from BS Physics 8th semester, the Women University Multan. My group members are Iram Zariab, Rimsha Hamid, and Alina Ayub. Our supervisor is Dr. Malika Rani. It is basically a device that gives the rapid detection of earthquake with the help of buzzer. In this poster, you can see the circuit of our project. Main component of our project is AND gate IC7408, which is controlling all the other components. In this device, we also used LEDs to modify our project. Another modification of our project is that here we used our reset button, due to which a device will not stop working after giving only a single sound, but it will continuously on to alert us. When we alert, then we have to press our reset button to stop the device. So this is the basic overview of our project. So this is our earthquake alarming device. Here you can see the working of this device, and you can see that how this device gives a rapid detection within a second. This is the breadboard circuit of our device. For this effort, I wanted to thank to my supervisor, Dr. Malika Rani, for her support, and thanks to all.
Assalamu alaikum. My name is Mahat Ramzan, roll number 22 from BS Physics Group 2, and our supervisor is Dr. Malika Rani. The name of our project is light sensor alarm for security purpose, and we have made this project to secure our homes, bank lockers, etc. We place this device in our room cupboards, bank lockers, departmental stores, and we save our precious things like jewelry, cash. It basically depends upon light. When light falls on the light sensor, it sends light and sends signal to the alarm, and it starts alarm. We save our precious things, and we have made this device with the modification, and this is very cost effective. Everyone can afford it. Thanks.
My name is Bishnu Ansari, Department of Physics, the Women University Multan. Group members are Myra, Amna, Asmara, and Ruba. Our supervisor is Dr. Malika Rani. The project is IoT-based smart electric lights. The main purpose of this project is control the lights of house by mobile phone. The modification is voice note system. And this is the poster of our project. There you can see the working of this project. When I say light 3 on, then it will be on, and so on, and then these all lights off, and as it is all lights on and off. This is the work of this project.
Assalamu alaikum. I'm Gulfaira from BS Physics 8th semester. Today I'm here to present my project, that is laser interrupt-based security alarm system. I've done this project under the supervision of Dr. Malika Rani. So here is the Principle: this system works as the laser transmitter emits the laser beam and the light is light receiver which receives the laser beam against the emitted laser beam. When someone tries to enter in our security system, the laser beam starts blinking and the buzzer goes on. The modification in our project is that one of it is set at our home and the other is set at police station. When unknown person tries to enter in our framework, the buzzer goes on at police station and the other buzzer goes on at our home. We can get notification and caught the thief or unknown entity. Thank you.
Assalamu alaikum. My name is Shumaila Satya. My project name is Intelligent Lock System. My supervisor is Dr. Malika Rani. The term smartphone point out about an address in which a home control is used to integrate the resident's different home automation system. It is a hidden lock. It is secure and safe to use. Conclusion: it is a latest project and the main concept of this is thesis in controlling the residential security for modern houses. Our main modification is Android app which is based on different security levels and we use ATMEGA328 instead Arduino. The basic principle behind the Bluetooth technology is that two electronic devices can be paired. Our diagram is Android app and monitored door lock. So this is end.
Assalamu alaikum everyone. I am Aisha Ghaffar from the Department of Physics, the Women University Multan. On the behalf of my group, I am here to presenting our project which is named by Single Axis Solar Tracker using Arduino UNO R3 which is supervised by Dr. Malika Rani. So, this is the poster of our project. This project is designed by using LDR, servo motor, battery, solar plate and the main part of the system. It is called the brain of the system and this is Arduino UNO R3. This system is highly reliable and low maintenance. It generates electricity from the sun. So, this is the video clip of our project. It shows that when light falls on the LDR, it helps to rotate the plate towards the light and absorbs more and more light. So, we are facing shortage of electricity in this era and shortage of electricity is increasing day by day. So, we designed this project to overcome the shortage of electricity. Thank you.
Assalamu alaikum. My name is Aisha Bibi from Department of Physics, MSc 4th semester. Our supervisor name is Dr. Malika Rani. Our project name is Simple Door Alarm. This is a poster of our project door alarm. The main reason for designing such a device was to protect our property because home security is the most important desired system of household in the world. As the Pakistan is the developing country, most of the people cannot afford very expensive and large-scale alarm system. So for this reason, we have designed our project in order to facilitate people. The main advantage of this device was its small size and easily affordable. As technology achievements have made our life much easier, so we have designed this device. It has various applications. Door alarm size is small, safe and easily affordable. It does not produce any sort of shock if it is fixed to a space where there is a chances of rainfall. It can also work well for both the cabinets and windows, easily affordable by all kind of people. Its component also does not require regular maintenance. It can work safely and reliably anywhere in the world. It is designed to protect our property and also to protect our property from fire, earthquake and electricity shock.
My project is automatic street light control system and we made this project under the supervision of Dr. Malika Rani and we have designed this project so that we can save the electricity wasted by the street lights because we see that especially in Pakistan street lights remains on even after the sun rises due to which a large amount of electricity is wasted. That's why we have designed this project. You can see that When you can see that the main component which used in this project is LDR, which detects the light when there is darkness. The light will turn automatically on, and after the sun rises the street lights will turn automatically off. This also saves manual work. And we also did some modification in our project. Our projects work on not only street lights, but we can use this to operate the on fans and any other device which runs on the electricity at night. And this is the model of our project, and thank you so much.
Assalamualaikum, my name is Muzammil Fida from MSc Physics. We design a device, water overflow detector, supervision of Ma'am Malika Rani. It is a simple device and detect overflow of water to prevent wastage of water and electricity. When water comes its specific level, we detect overflow of water. And buzzer start ringing and LED blinking, we turn off the motor and we prevent wastage of water. Basically, we use this device in our homes. Thank you.
Assalamu alaikum everyone. I am Sabanshir from the Department of Physics, the Women University Multan. On the behalf of my group, I present the project, the fingerprint recognition based attendance system under the supervision of Dr. Malika Rani. This is a poster of my project. The main purpose of my project is for hostel security, in which a known person cannot enter into the hostel without the permission of hostel warden or admin. The working of our project is very simple. Student who already registered in the system put her finger on fingerprint scanner and attendance will mark. Now modify our system from the previous system is that the hostel warden can stuck any student in any time if students misbehave with hostel warden. Thanks.
Assalamualaikum. My name is Halima Bibi, roll number 18 from MSc Physics, 4th semester. The name of our project is vacuum cleaner without electricity. We made our project under the supervision of Dr. Malika Rani. Vacuum cleaner is a simple combustion machine which removes dust and other particles from many places such as sofas, cleans, roads, offices, rooms, etc. Vacuum cleaner is a machine. The basic principle of vacuum cleaner is flow of air from lower pressure area to the higher pressure area. We are very thankful to our most respected ma'am, Dr. Malika Rani Sahiba, to give.
Assalamualaikum, I am Fatma Fadil from MSc Physics. My project is Electronic Eye Control Security System. It is supervised by Dr. Malika Rani. The basic principle of electronic eye control security system is LDR. When LDR is subjected to light, the comparator compares the voltage. The circuit functions to turn the light on and off depending on the amount of light received by the LDR. This is the working of our project. When the LDR observes a shadow, it starts ringing the alarm. This is the working on the model. As a person approaches the gate, the LDR observes a shadow and starts ringing the alarm. Thank you.
Rahim. Assalamu alaikum. I'm Nimra Niamat from Department of Physics. I'm going to present my project with the title Gas Leakage Detector Alarm and Pneumatic Control under the supervision of Dr. Malika Rani. Here we are controlling gas leakage through a sensor. Main theme of our project is that when there is the leakage of the gas in the gas sensor range, this will be detected, which in turn to activate the buzzer to produce a sound. And the red light will turn on, which indicating that the gas supply has been stopped and the valve closed. Thank you.
Assalamualaikum. My name is Sahra. I am in roll number 48. I am representing my group number 3. Our project is electromagnetic generator. We built this electromagnetic generator in the supervision of Dr. Malika Rani. Our project is based on Faraday's law. By rapidly moving magnets between the two coils of copper wires, we generate electricity which is able to on a 5-volt bulb. This is a low-cost generator and it is important for all over the Pakistan.
Hello.
Miss Assalamu alaikum. Miss Malika will join us shortly. I would like to invite Miss Professor.
Dr.
Yes, ma'am. Please continue, ma'am.
Oh yeah, Dr. Tajima is here. Hi. So please, Miss Malika is coming in a short while. Please start. I request you to start your presentation. Do you hear me, Tajima? Okay, let's start. We can't hear.
क्या कर रहे हैं? हेलो क्या कहते हैं सर? हेलो Fatima, can you? Yes, I'm here. Can you hear me?
Yes, ma'am. We can hear you, ma'am.
Okay. So
Now, can you hear me? Me? The host controlled my mute switch so that I couldn't switch off the mute. Now it's okay. Can you hear?
Yes, ma'am. We can hear you.
Yeah. Then please share my presentation file.
Ma'am, you can share. I have given the privileges of sharing, screen sharing.
Yeah.
Okay.
Yes, we can hear.
Can you see?
Yes, we can.
Yes, ma'am, we can see.
Okay, then let's start. Now, can I start?
Yes, sir.
Yes,
ma'am.
Okay. Thank you for a kind introduction. And I also would like to thank the organizers for inviting me to this conference. My name is Setsuko Tajima. I have just retired at Osaka University in Japan in the last March, and now working as a vice president of the Japanese Speaker Society. Okay, this is the outline of my talk. First, as a self-introduction, I will briefly explain what I have been studying, then introduce my career. My career is a rather exceptional case, but there may be something useful for young generation, young people. As a third topics, I will explain the present status of women in physics in Japan. In spite of our tremendous efforts to promote gender equality, women are still less employed as a professor, and female students are discouraged by many discomforts. Finally, I will introduce my activities to encourage girls to choose science as their specialty. Let me start from my research. The main subject of my research is the high temperature superconductivity. Superconductivity is the phenomena that shows zero resistivity below a critical temperature, Tc here. Simultaneously, a perfect diamagnetism called Meissner effect is observed. This is a quantum phenomenon in metals where electrons form pairs. It means fermions become boson. Because of zero resistivity, there is no Joule heating in metals, namely no energy loss during electricity transportation. This is a wonderful property, and it can make an energy revolution. However, we have to cool the materials below a certain temperature. It's very low temperature, so this is a bottleneck. This is a history of superconductivity. The superconductivity was discovered by Cameron Onnes in 1911. Here. And he found that the material shows zero resistivity. Mercury, he found that the mercury shows zero resistivity below 4.2 Kelvin, which is close to the liquid helium temperature. Cameron Onnes got a Nobel Prize for this discovery. After that, people have been trying to find a new superconductor with higher Tc. Among single element, niobium shows the highest Tc. Then, some binary compounds were discovered. And after the discovery by Cameron Onnes, the mechanism of superconductivity has been a puzzle for a long time, for more than 45 years. But finally, in 1957, here, BCS Baring Cooper Schrieffer, three physicists, has established the theory to explain why superconductivity occurs in a metal. These physicists also got the Nobel Prize. After niobium-3 germanium was discovered as a superconductor with Tc of 23 Kelvin, there was no report for new superconductors for more than 15 years. Then some theorists said that according to the BCS theory model, there should be an upper limit of Tc, and it's around 30 Kelvin. We call it a BCS limit. Then researchers started to search for superconductors of new category which do not obey the BCS mechanism. The search for non-BCS superconductors has become a new target and in 1986, Beddoes and Mueller found that the perovskite-related copper oxide exhibits superconductivity with Tc higher than 25 Kelvin. Just after their discovery, a lot of solid-state physicists, I would say that almost all solid-state physicists jumped into this field. It's a kind of fever. Then many copper oxides with higher Tc were discovered. So far, at and ambient pressure. So without any pressure, 135 Kelvin for mercury-based copper oxide is the highest TC record. I have been studying the mechanism of copper oxide superconductors for more than 30 years, but it has not been solved yet. The recent hot topics in superconductivity is the room temperature, not the copper oxide, but the room temperature superconductivity of hydrogen compound under very high pressure. So under 160 or more than 200 gigapascals. Some hydrogen compounds show the superconductivity at very high temperature. 250 Kelvin is close to the room temperature, right? So this is the hot topics. Let's see the application of high TC superconductors. The simplest application is to use them as wires for electricity transportation. Then using this wire, we can make magnet, motors, and electric generators. The magnetic levitation car is the most attractive application. The Japan Railway Company is constructing the new Shinkansen by magnetic levitation car. It will be open to traffic between Tokyo and Nagoya in 2025. Coming back to physics, we have a serious problem. The most important problem, essential problem, mechanism of high TC superconductivity of Q-plate copper oxide is not elucidated. Is it non-BCS superconductivity? Or why is TC so high? There are many other unresolved problems, such as the pseudo gap opening far above TC, or the competing orders, and so on. Let me remind you the basis of BCS theory. We assume here free electrons, weak interactions among them, the mean field theory, and Cooper pairs are formed in K-space, not in real space. The weak attractive force between electrons originate from the interaction with phonons, lattice vibration. Namely, phonon is the pairing glue. This is the basis of BCS theory. Then what is non-BCS? There are many theoretical proposals that use spin fluctuation or charge fluctuation as a pairing glue instead of phonons. Of course, these mechanisms are different from the original BCS, but the essential framework is the same as the BCS. I'm much interested in something others beyond BCS. One of the solutions is to consider that this superconductivity is close to the BEC, Bose-Einstein condensation regime. If the attractive force becomes very strong, the BCS system changes to the Bose-Einstein condensation system, BEC system. The origin of strong force may be the strong electron correlation near Mott insulator in the Q plates. Then, in the strong coupling limit, TC becomes high, and the precursor of superconductivity is observed at far above TC. I think that the Q plates are in the BCS-BEC crossover regime. One explanation. Okay, this is common phase diagram in the strongly interactive particles. Not only the electrons, but the quark matter is the same. Okay. One explanation why strong repulsive force, strong electron correlation, can induce strong attractive force in the following. The left panel illustrates the Mott insulator, and in the strong correlation limit. Here, all free electrons are frozen. Then the system is an insulator with antiferromantic order. When one hole is introduced in this system, the right figures, it destroys the introduced holes destroys the antiferromantic order. Namely, the energy of the system is increased. Then, the next hole, we can introduce the next hole. The next hole tends to sit near the first hole because it can reduce a total energy. This is a mechanism. So then the next hole again align and like that. So this is a mechanism of hole segregation in a doped Mott insulator. Carriers is in a strong correlation system tend to segregate as if they feel attractive force. So my understanding of high-TC superconductivity is the following. A precursor, we observed experimentally, a precursor of superconductivity observed in the Q plates at very high temperature is a hallmark of superconductor near the BCS BEC crossover. The pairing interaction in the Q plates must be caused by Mott order. A strong repulsive force gives strong attractive force. The coexistence of superconductivity and other competing orders may characterize the superconductors near the Mott order. So, let me move on the next subject, my career. I think that this may be a bad example of women researcher, I would say. I was born in Kobe in 1954, and in 1973, I entered the University of Tokyo with a strong. Can you hear? Any problem? Hello?
Yes, ma'am. Your voice is clear.
Okay, then I will continue. Okay, then okay, I entered the University of Tokyo with a strong wish to study physics. In this university, all students choose one department 2 years after the entrance. So I wanted to go to department of physics, but my father strongly opposed it. Then, to avoid discord with him, I went to the department of applied physics school of engineering. After graduating from the University of Tokyo, I entered NEC company as a technology researchers. So here again, because my father's strong opposition, I will go to the graduate course. Yeah, this is the first start to my physics career. In 1979, I got married and quitted NEC company because I had gone to Germany for 1 year study. I wanted to keep my position for 1 year at NEC, but it was not allowed. However, in Germany, at Karlsruhe University, I could do the research physics. So in that sense, I could come back the physics part. 1 year later, I came back to Japan, but I could not find a job and became a housewife. Then my former supervisor invited me to attend the seminar in surgery. It's only once a week, 1 hour. But even after having a baby, I continue to go to the laboratory once a week. It's only a very fine thread connection to academia. Then, Professor recommended me to do research in his lab. I was employed as a part-time research assistant. I did experiment at the university for only 2 days and did all works, data analysis, reading, and writing papers at home. It was a 2 days research.
Excuse me, ma'am. Your voice is a bit distorting. Can you please look into the parameters, please? Your mic parameters.
I didn't change anything of the parameter condition.
Yeah, it's clear now, but during the meeting, it was a bit distorting. It's clear now. Thank you.
Okay, sorry. Then I will continue. In this way, 4 years, I had no plan for future. I was simply enjoying physics research and obtained some results, research results. Then the professor recommended me to write a doctorate thesis. It was surprising to me, but more surprisingly, he recommended me to become an assistant professor in his lab. There was a reason for that. It was 2 years before his retirement, professor's retirement, and before that, 2 professors in his lab moved to the other institute. He needs a new assistant professor in his team, but he cannot guarantee the position for a new member after his retirement. I was originally then no problem, even if I lose the position 2 years later. It's a strange reason that I accepted his offer. After retirement, the professor was established the supervised research laboratory, which was supported by the government and 45 companies. He invited me to join his laboratory. Although I wanted to stay at the university, I could not refuse his offer. Then moved to the research laboratory in 1989 and worked there for more than 15 years. Unexpectedly, it was a research choice. There was no and enough money and time. So my 2 kids brought up. In this way, with the help of 2 mothers and the nursing and many supports, I could continue the research. I published about 300 papers during these 15 years. In 2003, the young person became a university student, and my husband moved to Nagoya because he got a professor position at the Nagoya University. I realized that I'm free. Then I decided to apply a professor position outside Tokyo and got a professor position at the university and worked there for 15.5 years. During this period, I became a member of Science Council and a member of working group member of IUPAP. In 2017, I was elected to be the Dean of the School of Science, School of Science. And at the age of 65, in March, I retired from the university. Now I'm working as a vice president of Japan. And during these 15 years, 2 sons got married. I feel very happy now. As you know, Japan is a country dominated by men. The gender gap index in Japan is the 121st among 153 countries. It's almost the bottom. The academic community is the same. For example, I was the first woman professor in gender in the Paris School of Science, and the first school dean at the university, and the first women professor at the Department of Physics among the seven top universities in Japan. It's very strange. I know that there are many excellent physicists older than me, but they couldn't get a position. So it's very strange. The young people, exactly what is fortunate and what is unfortunate. In my case, I wanted to go to the physics department, but I could not. This is unfortunate. So I chose Department of Applied Physics and Engineering School. Here I knew how interesting the solid state physics. This is fortunate. When I got married, I did not want to quit the company, but I had to do so. It's unfortunate. But instead, I had a chance to go back to pure physics research. I was a housewife without any job during a certain period, but it gave me a chance to become an assistant professor position. I wanted to stay at the university. I could not at the Tokyo University. It is unfortunate, but in the new laboratory, it was a research paradise here. And so, can we design our career? I could not. The life does not go as you want. Many things which disturbs your presence, marriage, child care, parent care, movement of family, sickness, and sometimes love, and so on. Then, what should you do? My style was to accept everything as my destiny. I did my best to find a possible way to continue research within a given boundary condition. I didn't make any effort to change the boundary condition. It may be a bad example for women. Yeah. But consider what's the most important thing in your life. In some cases, you may have to interrupt your careers. I learned from my experience. We can go back whenever we want. But research subject is always changing. If you miss one subject, another subject appears. Because physics is so rich. 3 years I have to become an expert in a relevant subject. Don't be afraid of making a break or change subject. Next, let's move on the third subject, physics in Japan. This is a figure that indicates the change of number of Japanese Speaker Society members just after the Second World War, 1945. There were only 2,000 members, but it increased rapidly, peaked out in the beginning of the century, and now it's about 16,000. Among 16,000, 6% are the female members. 30 years ago, so this is the red female ratio, red curve here. 30 years ago, 52%. So then it's now triple. It's really increased, 6%. For graduate students, the female, sorry, for graduate students, the female ratio is 12%. So then without students, female ratio is 5%. So it's clear that there is a leakage pipe. Why so few? This is a survey result at the university. We did this survey to all faculty members, professor, associate professor, assistant professors. About 600 professors among 3,000 sent back the reply. One of the questions was how many hours per week we work at the university. As you see, it's distributed from 10 hours to 80 hours. But in average, women's working time is 10 hours less than men. I made the same survey for society members, but the result was exactly the same. The reason is clear. Women have to take care of kids and do housework. In spite of such a shorter working time, the research output achievement, such as the number of applications and so on, was the same between men and women. Nevertheless, this shorter working time is one of the source to prepare men at the employment of faculty members. Another interesting question is, do you live together with your partner or live separately? I myself lived in Osaka alone, and my husband lived in Nagoya at that time. So we went back to Tokyo every weekend to take care of my mothers. So I know that there are many such couples. Interestingly, for women, couples are living separate here. Situation. For men, more than a half are doing only housework. Namely, their partners are the housewife. By contrast, most of the female professors have jobs. The ratio their partners is a researcher here or not. 27% of their partners are researchers. It's rather high in a sense. But in female professors, 63 of partners are researchers. It means that many female researchers get married with researchers, and the researchers move around the world from institute to institute or from university to university. It's difficult to live together for scientist couples. Then who takes care of their children? Survey indicates 100% case, in 100% case, female take care. Summary of the survey, at least in Japan, long-time working culture prevents the gender equality. Although the woman's working time is shorter than men, there is no difference in achievement between them. What is the meaning of long time working? It's a kind of culture. Nevertheless, women are less employed for academic positions because they are expected to work. So one of the most important problems is the long time working in Japan. And people are not aware of various problems, for example, anxiety and care alone and so on. Next, I would like to enter into new results. Our female students at the School of Science of the university made a survey to the female students in this March 2020. It's a voluntary survey because I was a teen at that time. I was shocked at it. They are feeling some discomfort and want to change the situation. Only 20 students replied, but the answer included many important messages. 70% of them have some experience of discomfort related to the gender issue. For example, some professor said to her, "I like your hairstyle, please keep it." Another professor said, "It was nice to discuss with girls, although it was a physics discussion." Someone said, "You don't need to search for a job, then choose the high school." Some teaching assistant, a doctoral student, said, "It changed that the girls gave a better result than boys." Or my school teacher said, "You should go to the department of chemistry, not the department of physics." What does it mean? And some girls said, because the experiments require physical power, the lab members seem to welcome men than women. And my professor did not expect me to become a researcher, and so on. It's hard to change unconscious bias. It's a lot easier with clear discrimination, but it's hard to change unconscious bias. That's my feeling. Okay, in order to change the situation, what can we do? One of my actions is to encourage girls and invite them to science. At the Japan Inter-Society Film Association Committee for promoting equal participation of men and women in science and engineering. There are 54 member societies, including the Physical Society of Japan. This committee holds science camp for girls. One is the Science Summer School for girls near Tokyo. Many girls get gathered to this 3 days camp in August. Another is the Science School for girls in Kansai area. Six big universities, Kyoto University, Osaka University, Kobe, and Nara Women University, and Osaka Prefecture University, Osaka City University, collaborate each other and conduct 6 programs from July to March. I'm deeply involved in this, so I will explain. Here is Kansai area. This is an area, and here is Japan. Expanding the figure. Here's Osaka. This is red circle. This red circle indicates the area. It includes many historical cities like Nara, Osaka, Kobe, and so on. So, this is Japanese schedule for this school. It starts from A program, and it includes in A, B, C, D, E, F. Can you hear? Yes? Sorry. Time is up. I don't know how many minutes. Just the program is behind. Can I continue this? 30 minutes behind. So then in the program a discussion with female university students and so on, and get together opening ceremony. In program C, and they attend a lot of experiments at the university. And the program E, they visit the companies laboratory for factory, where the engineers and researchers are working. The program is the jump on the first day to experiment, and on the next day each group make a presentation of what they learn. A kind of science camp. We have continued these activities for 50 years. So the situation becomes better. But the change is too slow in Japan. We cannot wait for the society change. The life is so no, we have no time to complain about the situation. I think that it's better to concentrate on your research for what you want to do. Okay. Thank you for listening.
Thank you, Tajima. Thank you very much for such a nice presentation. We came to know a little bit about history of superconductivity, and about yourself, about how you develop your career in physics. This is something for young physicists to build up their career in physics. I'm glad you are here and you share your experience in physics, and I know how difficult it is for us. हाँ भाई क्या कह रही हैं मैडम कैनन अच्छा चलो thank you, Tajima. You are to be here, and you accepted our invitation and honored us. And I hope young physics students will learn a lot from your experience. Mostly the women women leave their career and disheartened by being a housewife and having children. They find themselves not doing anything. I appreciate your efforts for continuing physics as career, and thank you very much once again. If anybody has question, we will make it at last. Now I invite Ms. Cannon to deliver her talk. Is she here? How about Dr. Asghari Maqsood? Are you here, Asghari? It is 12:30. I think Dr. Asghari Maqsood will deliver. Are you here, Asghari?
Ma'am, they are not currently available. I would request Ms. Malika Rani to kindly reach him.
Let's talk about your career, and she is going to join us. Ms. Cannon Kennelly is joining at 1 p.m. Yeah, Malika? Huh. Okay.
Aziz Fatma, I think it's the turn of Dr. Yasmin.
So I request Dr. Nigat Yasmin for her presentation that is already recorded. I request the administrator to start her presentation. Thank you, Tajima. Thank you for so kind of you, so nice of you to have you in this conference. Thank you very much.
Madam Nigas Yasmin was busy in a meeting at Director Office, DG Office. She will join us at 4 o'clock and she will also join us on closing ceremony. So we have recording video of her and we're just playing it.
So why?
Scientist, Director Nilo. I am very thankful to the organizer to providing me this opportunity so that I can represent the NILO on the forum of these universities as an R&D institute. NILO is a PSDP funded project. It was started in 2006 with a seed money of 20 million, and the total fund that was given to the NILO for the building of establishment of NILO was 740 millions. And it was completed in a period of 6 years from 2006 to 2012. We shifted in this new building. This building was also constructed with the help of these funds. This is the only project or the only institute that was purposely built, and it has some objective for its establishment. The objective of this establishment was to establish a world-class institute in the field of lasers and photonics, to develop a close collaboration with universities for human resource development, leading to the MPhil and the PhD in lasers, photonics, and its applications, to assist the universities for sustainable research in the field of lasers and its application through close collaboration, and design and fabrication, laser systems for medical, agriculture, and industrial applications. We have designed the many medical laser. In agriculture, we have designed the laser land leveler, and then we applied some lasers in the industrial application too. And to establish one of the purpose of this institute was to establish an industrial linkage through the joint venture and transfer of technology. In the research and development, this institute has some objectives in the field of the quantum devices, such as the diode lasers and the optical diagnostic techniques. Here you can see the organogram of the NILO. It has 6 divisions: laser spectroscopy division, technical services division, material division, academics and optronics division, laser development, and the special project division. Agri, and the Biophotonics division. You see that we apply the laser in the agriculture and the biology also. These open six divisions are looked after by the director and the deputy director, which seeks the advice from director general and the member science. Here is the manpower of the NILOB. We have only 81 scientists. PhD out of these 81 are 37, and MPhil and MS are 44. Officers non-technical are 4, staff technical 61, non-technical staff is 60 only. Different type of research and development activities are being carried out at the NILOB in the field of scientific research, where we have research in the laser spectroscopy, laser cooling and trapping, atomic time and the frequency standard, quantum devices, miniature sensors, quantum optics, lidar, light-induced detection and ranging, terahertz spectroscopy, agriculture and biophotonics, materials and plasmonics, thin film characterization, modeling, and simulation. And at the development side, we have developed the femtosecond terawatt laser systems, and also we have made the laser for the medical applications such as the photodynamic therapy laser, low level laser therapy systems. And we have made the me-scattering radar indigenously. We have developed the sun photometer, laser ablated time of flight mass spectrometer, auto laser land leveler transmitter, thin film coating plant, optical mammography systems, real-time PCR machine, digital instrumentation for the lab such as the lock-in amplifier, laser beam profiler, and NQR detector. These are the locally developed equipments. In the field of laser spectroscopy, we are pioneer in Pakistan. This is a very established lab, and I think more than 35 years has been passed have been passed for this lab is in operational. And we have many different type of laser optics and non-linear crystal in this, different type of the vacuum systems, the chambers, and gadgets in this lab. This lab has published more than 100 papers in the International Journal of Repute, and different type of the spectroscopy has been done in this lab. This lab is working so well that we received an acknowledgement letter from the National Institute of Standards and Technology, NIST, USA, for the determination of the ionization energies of the zinc and the cadmium most accurately in the world. In this lab, we investigate the rate states of the different elements, photoionization cross-section measurement of the excited states, oscillator strength of the Rydberg transition, mass spectrometry, trace gas analysis using the cavity ring down spectroscopy. This is a project of the PSF of approximately 2 million. And these type of the research, basic research is going on in this lab. In the same lab, we have developed the laser ablated time of flight mass spectrometer. This is indigenously developed, and currently it's working in the range of from 1 AMU to the 150 AMU. This is without reflectron. If the reflectron is under process, when we will made it and combined with this time of flight mass spectrometer, then its detectable mass range will be increased from 1 to 350 AMU. Currently, we can do the lithium 6 and the 7 isotope ratio, boron 10 and 11 isotope ratio detection for the SPT organization, and we can also sell this time of flight mass spectrometer to the different universities or the research or institutes. We have already received a letter from the UET Lahore. They need this equipment, and currently this is working from the 1 to 150 AMU, and the mass accuracy of this system is less than equal to 50 ppm. Mass range is 1 to 150 AMU, and commercially it is available. And the reflectron will be a part of this system, then its range will be increased, and this can be used for the higher Z elements such as the uranium 235 or 238. This is under process. In the same lab, we have also a laser-induced breakdown spectroscopy equipment. LIPS is an atomic emission spectroscopy technique which uses the energetic laser pulses to produce a plasma on the sample surface. So when the plasma is produced, then analysis of the sample is very simple. In this, we can analyze any sample, gaseous sample, liquid or the solid sample without preparation of the sample for its analysis. We send the laser pulse on the target and then the backscattered light is then collected by a telescope and then it is fed to the LIPS spectrometer and then analyzed with the help of the computer which has the different type of the software. And the LIPS analysis has been performed on the liquid and the gases, developed the LIPS spectrometer, calibration facilities, customized system for the specific application can be developed, explosive detection at a standoff distance. All these applications of LIPS we have done at NILU. In the same division, we are also doing, hello? In the same division, we are also working on the remote sensing activity, means the atmospheric studies. We are working on the different type of the lidar. We have made the mescating lidar. This is the data from the mescating lidar, and the software for this mescating lidar is also prepared at the NILO. And now we are working on the differential absorption lidar and the Doppler lidar for the measurement of the air velocity is in progress. Then we have the objective to work on the hyperspectral lidar and the me lidar we have done. With these lidar, we can study the cloud detection in the lower and the upper tropospheric atmosphere, aerosol detection and the temporal evolution, extension and the backscattering mapping of the atmospheric constituent, real-time profiling of the thermally generated processes in the planetary boundary layer, and develop the software for the lidar data acquisition and the processing. With this mescating lidar, we can process the atmospheric data online and in real time. We have also made a sun photometer which uses the LEDs as a detector instead of the in the PMTs or photomultiplier tubes or the photodiodes. This is a very cheapest equipment which can study the atmosphere. This we have developed indigenously, and the calibration of the sun photometer is done by the Globe sun photometer, which is internationally available, or we get the data from the Aeronet or the Moody's, which are the two satellites which pass over the Pakistan. We measure the aerosol optical depth calculation and verification with the help of the sun photometer, and the atmospheric turbidity and angstrom exponent determination using the sun photometer data. Upgradation of the sun photometer to the multi-channel devices for the estimation of the hygroscopic constituent of the atmosphere. This is a two-channel data, a two-channel sun photometer, and the 5-channel sun photometer is in progress, which can analyze some more data. Then another division is working on the laser cooling and the trapping of the atoms. Equipment that we have in this lab are here, I listed them: diode laser system TA100, DL100, and the booster magneto-optical trap cell, quartz, and cesium vapor cells, acousto optical modulator, optical isolator. In optics, we have the prism, beam splitters, mirrors, lenses, half-wave plate, and the quarter-wave plates. In vacuum system, we have the rotary turbine and the ion pumps. These equipment I am telling all of you is because we have this equipment, and you are more than welcome to use this equipment. And in the research activities, with these we have made the injection locking of the diode laser for the CPT and the Raman transitions, electromagnetically induced transparencies, and the coherent population trapping in the cesium mode, and the cesium mode as an optical lattice. These experiment has been done on these in this lab. And next group is working on the development of cesium atomic beam clock. Objective of this is to develop an accurate time and the frequency source. Accuracy of this will be 10 to the power minus 10 second. And the scientific activities are development of the high power microwave field for the Ramsey interferometry, and the application of this is for the R&D application is verification of the physical constants such as alpha and R, and the seismic radar ranging and the position finding. And the commercial application of this is to set up time and the frequency standard for the Pakistan. Because we do not have our own standard time and we borrow the time from the American GPS systems, and if they block our GPS system or the time we lost the time, then our military communication, navigation, surveillance, missile guidance, that all will be failed. So it is dire need of time that we should have our own Pakistan standard time. And NILOP is working in this direction, and soon we will be able to build the atomic clock. And one other group is working on the quantum optics. Theoretical group is working in the field of quantum information, quantum entanglement, entanglement generation among the discrete variables such as the atom, field, quantum dots, surface plasmons, etc. And the entanglement generation among the continuous variables such as the quantum beat lasers and the parametric down conversion, entanglement protection, and the environmental engineering, atom optics, and atomic scattering. And this all is the theoretical group working on, and the experimental quantum research is in the atomic coherence effect, EIP, ATS, and the CPT, atomic beam clock, compact atomic clock, atomic interferometry. These are the experimental setup the group has established at NILO. And other group is working on the fiber Bragg grating based temperature sensors. Experimental setup, we have the ASE light source, EXO test and the measurement system, fiber Bragg grating and the Peltier unit as a variable temperature source, real-time temperature response curves. Size of this sensor, these are very minute and miniature sensors. The size of this sensor is, dia of this is 250 micron and the length 5 to 10 millimeters. And electromagnetically immune. These devices are electromagnetically immune. And the applied projects are the development of the temperature sensor, development of the stress sensor, development of the flow sensors, cantilever-based interferometric stress sensor. And this, we have developed this flow sensor and the temperature sensor and studied them. We have a rich material division at NILO. It is working in the different fields such as the growth and the characterization of the gallium nitride-based light emitting diode and the laser diode structures, gallium nitride-based alpha and the neutron detector. Currently, we have developed the neutron detector and it is in the process of evaluation. Deposition and the different materials like metal, dielectric, and the semiconductors, thin film deposition of the semiconductor materials such as the zinc sulfide, zinc selenide, cadmium sulfide, cadmium telluride, vanadium oxide, etc. for the various optoelectronic and the gas sensor applications. Then one group is working in the piezoelectric, triboelectric nanogenerator devices, and also they are working on the development of the organic light emitting devices, development of the thermoluminescence materials for the TLDs. This is also under the process. Quantum dot-based optoelectronic devices, development of the EMI shielding materials, different materials have been developed and tested, and development of the nanofibers of the functional materials by electro-spinning method. And one group is working on the micro-nano fabrications. We have a rich lab under one roof. We have growth and the fabrication facilities such as we have the MVE. This is a state-of-the-art machine we have at NILO. We have the thermal E-beam evaporation system, reactive magnetron sparkling system, laser pulse deposition system, CVD system, and the LPCVD. This is currently we received and under the process of installation. Photolithography system is also we have an ICP etching system. These all are under one roof at the NILO, and we are generating a rate list of these equipment so that the different universities and the institute can get their work done from here and they can use this facility because these are very expensive and it's not possible for all the institute to have these facilities. And then we have a characterization, a very good characterization facilities at the NILO. We have field emission scanning electron microscope and the EDX. We also have the spectroscopic ellipsometer. We have the atomic force microscope and the Raman and the PL. And we have the electroluminescence, IV, CV, and the Hall measurement system, and we have the spectrophotometer. These and currently we have received the XRD, and that is under the process of installation at the NILO. So we have a very rich characterization facility at the NILO, and you all are more than welcome to get the benefit from it. Then we have an ultra short laser pulses group, and this is working for the development of the ultra short laser pulses of the 10 femtosecond high power 100 terawatt laser systems. And currently it has the 3 stages. We are at the second stage, that is we have achieved the peak power of the 1 terawatt and the pulse width of the 10 less than 10 femtosecond and the peak intensity of the 10 to the power 16 watt per centimeter square. And the third stage is under process. And finally, we will be able to get a peak intensity of the 10 to the power 18 watt per centimeter square. Its application it has a very broad application: proton acceleration, neutron generation, free electron laser, X-ray generation, gamma-induced nuclear reaction. So many applications of this laser are available. And we have designed the clean room also. This is a clean room which is basically planned at the NILOP and designed and then constructed at the NILOP. We have a rich human resource development here at the NILOP. Then one group is working on the transient optoelectronics. Objective of this is development of the technology for the measurement of the extremely fast time scale event using the optics and electronics, such as the EM spectrum of the, for instance, the UV visible near 400 nanometer to 800 nanometer, X-rays of the keV range, terahertz less than 1.5 terahertz, microwave less than 6 gigahertz. And the current responsibilities are electromagnetic simulation using the CSD suite and the ADS, and the planned capabilities are measuring of the optical and the X-ray pulses at the picosecond and the femtosecond scales. This is the layout of the stick camera. And second, we also developing the secondary ion mass spectrometer time of flight SIM. First, I have described the laser ability time of flight mass spectrometer. This is another secondary ion mass spectrometer. The important section of this are the primary ion source, generation of the secondary ion, acceleration of the secondary ion, time of flight analysis, and the application of this is isotopic analysis, dopant concentration in the semiconductor, and the nuclear forensic analysis. Then the development of the fluorescence is the biophotonics group of NILOP is working, has developed this fluorescensor. This was a project of the PSF, approximately 1 million, and we have developed this at the NILOP. This uses the fiber optics fibers for the delivery of the laser light source, and the back reflected light is picked up from a fiber, and then it is passed from the long pass filter and then fed to the spectrometer, and the data is analyzed with the help of this computer. And the potential application are the diagnosis and the monitoring of the skin cancer, detection of the adulteration in the food items, just as the milk, turmeric, desi ghee, clarified butters, edible oil, etc. And this we use for the detection of the adulteration in the desi ghee using the portable fluorescensor, because when the fluorescensor is applied to the desi ghee, they have entirely different peaks for the banaspati ghee and for the desi ghee. So on the basis of these curves, we can differentiate between the desi ghee and the banaspati ghee. Also, the adulteration, if it is done in the ghee, we can find it out. And then this can be used for the determination of the iron and the zinc content in the wheat by inducing the by the laser induced breakdown spectroscopy LIBS. LIBS is a purely experimental setup. We are applying it to the bio in the field of the bio and the agriculture also, because we have a different varieties of wheat that have a different iron and the zinc quantity in them, and some has the yield better than the other, but they are not rich in the iron and the zinc. So with the help of this facility, with the laser induced breakdown spectroscopy, we can differentiate the wheat crop which has a much iron and the zinc in that, also with the grain productivity much, or the we have the large yield and with the iron and zinc. So on the basis of this, we can use the labs in the field of biology also, agriculture also, sorry. And then we have a development of the early detection of diseases in the plant with the help of the laser. With the naked eye, you cannot separate the healthy plant and the rusted plant. And by the use of this, applying the light to these plants, so we can differentiate between the healthy and the diseased plant. And so we cannot waste our water and other things for those plants which are not healthy. So we can save a lot of money on the basis of early detection of the disease in the plants. About 70% of the water can be saved. Laser scanning electron microscope also we have. It has a different type of the laser, argon 458, 477, 488, 540 nanometer laser, and the helium neon laser in it are the 543 and 633 nanometers. And different magnification are available in this confocal microscope, and this is very useful for the different analysis, and layer by layer analysis can be done by this scanning confocal microscope. Laser system for the photodynamic therapy. This is recently built. First we have this photodynamic therapy system, then we added this system with it. This showers the droplet of water and also the cool the skin where this laser is shine for the treatment. This laser emit at the 635 nanometer light with a variable power up to the 2-watt fan with the mist system to produce a cooling effect on the laser irradiated area. This is also developed and this is used at the Swat for the sandfly bite on the skin, which was not healing with the medicines. So they applied the photodynamic therapy on the skin in only, I think, the 1 or the 2 setting. The wound was completely healed. Then we have a nanomedicine research lab at Nilo. It is working on the nanomedicine lab. It has 4 labs. It has a nanomedicine lab, cell biology lab, animal optical imaging, and the nanotherapeutic facilities. And the research themes of these labs are polymer-based drug delivery, ultrasound-mediated drug delivery, laser-induced nanotherapeutics, developing the contrast agent. And they have the sophisticated equipment such as the flow cytometer, fluorescent cell imager, nanosizer, zeta potential, zetator, and ultrasound animal optical imaging. Special facilities of this lab are the particle synthesis, characterization, formulation, development, in vivo genotoxicity assay, and the viability assay, tumor imaging, and therapeutic monitoring. This is a rate list which we have generated for all the equipment which we have at the NILOB, so that the different universities, institutes that are lacking these equipments they can use these equipments with the defined rate list. This is under process of approval. And these are the few products which NILOP has developed. This is a PTT laser therapy system, fluorescence, sun photometer, NQR machine, time of flight mass spectrometer, and the auto labder system and NQR machine system. We made a state-of-the-art workshop also at the NILOP, and we made the vacuum fittings of different KF fitting, CF fitting in the vacuum chambers. This is a vacuum chamber made in our workshop, and these are some vacuum fittings that are of the international class. And these are the products, optical mounts we have made for the NILOP we made, and also we are working for the OLab and the other institute. These are the parts which are made at this workshop. These are the parts of the autolabor system, and these are miscellaneous parts at the NILO. There are some products which are under development. These are the development of the optical mammography with the collaboration of the Lund University, Brazil, design and development of software-based lock-in amplifier, design and development of the laser microphone, design and develop the laser beam profiler, development of the qPCR machine. This is under process and near to completion. And these are academics. NILOP has awarded the status as the Constitute College of the Pias for the PhD in laser and the semiconductor physics. And NILOP also offers the research supervision to the MPhil, MS, and the PhD student for the public sector universities. PhDs, which has completed the PhDs are 9, and the in progress are 12. And the students supervised in the different years. 2015 we have the only 4 students, in 2019 we have the 12 students, and now the number has also increased. And research publication, we have international research. In 2015 we have total 31 research papers, and 2019 it's 40, and up till now in 2020 we have published more than 40 papers. And these are the courses which are offered by NILO faculty. And there are certain projects which are in progress or we have submitted because we do not have so much funds. So we try to find the funding from the for submitting the PCC, PC1 from the PSF and PC1. And these are the different projects which we have submitted. Some project we also submitted the Park China joint project of the 20 million. 2 project we have submitted 20 million each. And in future plan, we have to develop the dilator for the chemical biological warfare agents. We have to fabricate the rubidium cell atomic CPT clock with the accuracy of 10 to the power minus 10 second, and the development of 300 terawatt femtosecond amplifier, set up for the LPCVD facility for the fabrication of the MEM devices, 5-channel sun photometer, establishment of the Pakistan atomic time and the frequency standard, development of the ultra-sensitive fluorescence spectrometer, development of the plasmonic-based optical biosensors, green synthesis of the nanoparticles. These are the future program, and the some project we have submitted to the Pak China high spectral resolution radar with the laser diode sources and near IR 800 to 900 regime, and the realization of the laboratory scale atom interferometer using the BEC of the cesium-133 and rubidium-87 atoms. These are the different projects we have submitted in the dashboard, and thank you very much for listening. You are welcome for the research collaboration. Thank you.
Thank you very much, Nigat. You have given a very impressive and introduction and details of the project going on in the NELOP. We came to know a lot about NELOP, what is being done in NELOP. Thank you very much. And I think our session is going to close. And I request the participant, if they have questions, they can raise hand and hear from participant. They like your presentation, Dr. Nigat, and one day I will invite you for Center for Physics Education to address women student physics and other teachers to interact with you and have interaction with you, and it will be encouraging for women or motivate young. Hello? Can you hear me?
Yes, ma'am, we can hear you. I will request the other participant to please mute your mics. If you have any question, then you can unmute your mic and ask a question, please.
Is there anybody? Are there any questions?
Ma'am, I think no one has a question, and I think we should move to the next session. Madam Anisa Kamar will chair the next session. Madam Anisa Kamar, are you here?
Yeah, I'm here, Malika.
Yes, ma'am. Thank you, ma'am. Ma'am, please start the next session. Madam Canon from Turkey is with us.
Turkey.
Yeah, she's with
Okay.
us. Please, yeah.
Hi.
Hi.
Dr. Kamar
Oh.
will be here the session.
Thank you so much for giving this opportunity, especially the Women University of Multan, to chair this session. And I would just like first to say thanks to the Vice Chancellor as well as special thanks to the Malika Rani to organize this international conference. And it's pride for the Pakistan that in a very short span of time, we first organized the Regional Conference of Women in Physics in 2016. And then in 2019, we organized the second regional conference on women in physics in Nepal. And now, for the third time, it's the next turn of Pakistan that Pakistan is going to organize this women conference, especially. And I really appreciate your efforts, the efforts of the organizing committee, the efforts of the Vice Chancellor of the Multan University. And now, I have some requests to the organizing committee as well as the panelists. That is it possible that we are arranging a very short meeting regarding to the problem of the women in Pakistan, and I would like to organize the working women group of Pakistan there, if possible. So I'm just going to invite Dr. Canon from Turkey, and I would just like to say, first of all, good afternoon and then salam to you. So, Canon, you have a chance that you present your work well, and hopefully it will be much more attractive for the Pakistani women to attend your conference, to attend your presentation. So, welcome, Canon.
Thank you, Dr. Fatima. Dear Chair and participants, greetings from Turkey. I'm Canan Kandilli. Firstly, I wish all of you and your family health and peace in the pandemic conditions. I would like to thank you for this invitation, and I should say that it's an honor for me to be with you. But I must say that I would like to apologize for my English because I cannot find right opportunities for the last years.
Don't worry about the language, because it's an international language. It's not our own language, so don't worry about the language. Okay.
Thank you for your understanding. Let me introduce myself firstly. As I said before, I'm Canan Kandilli, 42 years old, 42, and married. I'm married and having 2 children. My son is almost 4, and my daughter is 11 years old. I'm working as an associated professor doctor at mechanical engineering department. Yeah, mechanical engineering department at Uşak University in Turkey. Let me mention Uşak. Uşak is a city, province, a little province located the west part of Turkey, west part. And I am head of energy division of my department, mechanical engineering, since 2009. I completed my PhD study on solar energy, and I was lucky actually because my bachelor degree was on physics, and I had enough background for solar energy and mechanical engineering. Um, some women issues. I'm only a female academic person in my department, as you guessed, in mechanical engineering. There are many challenges to being a female academic in physics, but this challenge is at the peak for the mechanical engineering. In my department, I teach undergraduate and graduate courses such as physics, thermodynamics, heat transfer, energy management, renewable energy resources, etc. And I have 2 Master of Science and 2 PhD students. We studied some solar energy projects, and my graduate students work as scholarship holder in my projects. In our country, there isn't any distinction between teaching and research study. So we have to teach while we study on our project. For example, in pandemic condition, last semester, in pandemic quarantine, I had 38 hours per week to teach courses. And another important issue in our country, the number of undergraduate students. It's very high. For example, in our department, the number of the undergraduate students per academicians is about 115 per academicians. It's very hard conditions for us, for academicians, for especially women academicians. Regarding to physics in our country, there is a perception that physics is a science that mostly men are interested in. It's not possible to say same thing for chemistry and biology, but there's a perception about physics, unfortunately. For chemistry and biology, in these areas, women have an obvious viability. As for mechanical engineering, as you guessed, it's very, we have a very hard conditions. I want to share a little memory. I completed my PhD study on concentrated solar energy system, and I obtained a postdoc grant from ETH, Institute of Energy Technology, from Zurich, Switzerland. When I started my postdoc studies, I was expecting a baby, my first baby. And one day, while talking about our future plans, one of my colleagues, a male one, said that, how do you hope to become a professor while expecting a baby? In his opinion, being a mother could prevent academical careers, academical studies. It's possible to expose this type behavior all over the world, and we should go ahead. We should continue our studies. I want to say that. And now I would like to mention about my research project and I want to share my screen, okay? Yes. Is it okay? Can you see the presentation? Okay.
Yes.
Thank you. This is my story. Undergraduate physics, PhD on solar energy. Having first child, then having and losing the second child, and having the third child, and ongoing projects on solar energy. This is my story. And now I would like to mention solar energy. It's my main topic. It's my main topic. Solar energy has many advantages. It's plentiful, clean and renewable, available for local solution, independent and free for all over the world. And solar energy systems give us solutions for many problems. To solve, we can solve many problems with solar energy. You can, if you want, you can heat your water, you can produce electricity, you can heat your air, etc., and low-cost systems. These systems. Also, solar energy has disadvantages because it needs large areas, non-continuous, unsteady, has storage problem, high investment cost, and shading problems. My PhD study was on concentrated solar energy. Especially I studied concentrated solar transmission, concentrated solar energy by optical fibers, because so concentrated solar energy is very important topic. Higher solar flux, you can get higher solar flux, you can get higher temperature, you can get bigger power by concentrated solar energy, and available for various applications, concentrated photovoltaics, CPV, steam production for industry, and solar lighting. Also, concentrated solar energy has disadvantages because it needs higher solar energy potential, having design limitations, relatively low efficiency if we compare with flat solar energy systems. After my PhD, I focused on spectral beam splitting because I understood that we cannot employ full of solar spectra, and we should find a way to increase the efficiency of the solar energy systems. So one way of the increase of the solar energy system, spectral beam splitting, because its solar spectra has a wide range of nanometer, and we cannot convert the electricity or thermal energy, all of them. Spectral beam splitting is a promising method to achieve high efficiency for solar energy conversion. This method is separating the full solar spectra into different wavelengths by an optical device. And this method has many advantages, such as reduction of heat losses, in solar energy application and utilizing all spectra in an efficient way. We can increase the overall efficiency of any solar energy systems by spectral beam splitting method. Spectral beam splitting method could be employed for concentrating photovoltaic modules or photovoltaic thermal systems called PVT systems. Spectral beam splitting provides most effectively utilization from the entire spectrum of solar energy, possible to enhance a remarkable increase on the overall efficiency. You can see some device called hot mirror and cold mirror. We can use these optical elements for spectral beam splitting. What are the hot mirror and cold mirror? Hot mirror is particularly reflective surface reflective infrared and ultraviolet radiation in the region of visible radiation passes behind. On the other hand, cold mirrors reflect the visible region radiation and pass infrared and UV radiation. We can employ these optical elements in our solar energy systems, and this graphs transmission characteristics of hot mirror and cold mirrors. You can see the systems, concentrated solar energy systems focused by my PhD thesis very long time ago in a Solar Energy Institute. We can transmit concentrated solar energy by optical fibers. You need a solar concentrator, and we can focus solar flux on the focal point. In this picture, on the focal point, a fiber optic, there was a fiber optic bundle, and I had used an optical filter to prevent melting the optical fibers because a very hot point, as you guess, and this is solar tracking systems and light dependent resistance, and I had used this transmit concentrated solar energy for solar lighting in my PhD thesis. It was a very efficient system. Anyone can find some articles about these systems. Another project, after my PhD thesis and my postdoc studies, I came back my department, and I had some projects. This is project one, a novel concentrating photovoltaic combined system. In this system, I had used hot mirror. So I separated infrared radiation and visible radiation. Visible part of solar radiation has been used for photovoltaics to produce electricity, and the other parts can transfer vacuum tube and we can get thermal energy. Another project after that, again, this project was on concentrated solar energy for lighting power generation combined system based on spectral beam splitting. I had employed cold mirror in this project and Stirling engine. We can pass the infrared radiation, infrared and UV radiation to Stirling engine and reflect the visible part of solar radiation to inlet of the fiber optic bundle. So you can increase the overall system efficiency. Another image and thermal image, and you can see the temperature on the entrance of the fiber optic bundle. We can get higher temperature on Stirling engine. I want to mention some remarkable result of the project. The overall energy and exertion efficiencies of the systems were calculated respectively. The cold mirror does not hold any part of solar spectrum and has been really cold during the experiments. And radiative and convective heat losses for Stirling engine should be minimized to obtain much more solar power. And we get high lighting efficiency for the system. After this project, I decided to study photovoltaic thermal system because to study and to make experiments on concentrated solar energy is very hard topic, experimental studies. And my third project was on investigating the materials for photovoltaic thermal systems, PVT, called PVT, and evaluation on the effects of system performance. What is PVT? PVT is a combined system. We can produce both electricity by PV cells and we can obtain thermal energy by the pipes and working fluids. You can choose water or cooling fluids for working fluids. In these studies, it's important PV material. It's important spectral response range of the PV material. I mean that you can use monocrystal or polycrystal solar energy systems. Another important issue, you can use excessive heat load from the system, increasing internal resistance, decreasing instant efficiency, decreasing long-term efficiency, degradation PV material during long-term period. If you cannot take the excessive heat from the PV, the efficiency, electrical efficiency can decrease and you can expose some problems. And you can use fast change materials combined with photovoltaic systems. Many type of there are many type of fast change materials. You know, most commonly used paraffins, latent heat storage, for heating. You can employ for heating and cooling. Steady conditions, you can obtain constant temperature, and you can obtain thermal energy. PCMs have a high thermal energy storage capacity, lower storage volume, and they are available fast change temperature for storage and waste heat recovery. So it's very available for PVT system, photovoltaic thermal systems, and available for the application at constant temperatures. The main problem for conventional PVTs, we could not obtain steady and regular thermal energy at a constant temperature. However, if you employ a material integrated with photovoltaic thermal systems, you can reach much more steady state conditions at constant temperature, and you can store much more thermal energy. Evet, yes, this image is from our project and experimental system. It's experimental system established in the roof of our department. And results of the PCM studies integrated with photovoltaic systems. And I want to mention ongoing project. Nowadays, last year, I established a new laboratory, energy laboratory, in my faculty. In this new project, we are working on photovoltaic systems and some materials. We composed some new materials to increase the efficiency of photovoltaic systems. It was very hard work to establish a new laboratory. And this is a lamination machine for photovoltaic systems, lamination machine. And we can produce our photovoltaic systems and we can laminate produced PV systems, PV panels. These are monocrystal photovoltaic panel. And also we can test our PV panels, PV and photovoltaic thermal systems. And we try to develop some energy storage material for PVT systems in my ongoing projects, in our ongoing projects. Yes. We based natural zeolites and we produced natural zeolite plates and we test thermophysical properties to combine, to integrate with photovoltaic thermal systems. And at the end of my presentation, I want to say that half of the population of any society is women. Therefore, only countries that can bring women's power to society can develop and continue their development. Finally, I would like to thank you for this opportunity, and please don't hesitate to communicate with me. You could send emails for any issues. Thank you for this opportunity again, and stay blessed. Thank you.
Thank you, Tanan, for a very good representation. The first thing I would just like appreciated that you have a background of physics and then you did your degree in mechanical engineering. So the combination of physics and then mechanical engineers is work well, and you are probably, I'm proud in you that you are doing a lot of applied projects, which is benefit your society. We have already this type of shortage of electricity problem in Pakistan. So in my opinion, it's much more good opportunity for us that why not to collaborate with your university as well as with you to resolve this problem in Pakistan. If anyone have some question you would just like to ask from Tanan, then you have an opportunity. Otherwise, you can ask your question via chat. And thank you again, Tanan. And we really appreciate your effort. And throughout the world, it's not the problem of only Turkey or in Pakistan that women are a sufferer most of the time. Throughout the world, we all women facing the same type of problem. And if we all women are sitting together and you are start collaborative work, it might be possible that one day we can change the fate of the world, especially the women scientists. So one day will be, it's a very great pleasure for us that for the first time, the Director General of the CERN is a woman. She's a woman. So in the history of the CERN, so it's a great possibility that if we are working together, so we can change even the fate of our country, the fate of our region. So I appreciate your effort again. And again, thank you for your very informative talk. And stay with us up to the end of the session. And on the behalf of the organizing committee and on behalf of the University of Women Multan, I would like to again say thanks to all. Okay, Tanan. Thank you. So I'm just moving to the next speaker. Our next speaker is Dr. Asghari Maqsood. Malika Rani.
Madam Asghari Maqsood is busy in a meeting. So we will go to the next speaker, Saida Afshin Zahra. She is ready and she will deliver a talk. Please invite her.
Okay, so Afshin Zahra, the next speaker is Afshin Zahra. I would just like to, Afshin Zahra is from the Nust University, Islamabad, and she introduced herself and then her topic as well. Afshin Zahra, Zahra, definitely you have a short span of time, it's just 30 minutes. So try to wind up your talk within 30 minutes, okay?
Yeah. If I am accessible to share my screen?
Yeah, why not?
Yes, you are.
Okay.
I have allowed. Now you can share.
Okay, thank you, ma'am. Thank you. Okay, is it visible now?
Afshin, there is a problem in your mic. Yeah, we can see your presentation.
My mic isn't working, or you can't hear me?
No, we can hear you, but there is some sort of sounds behind the mic. So the sound is not too much clear.
Okay, I have Nothing down. Okay, let me.
Let you just start it, okay? Yeah. If we
Yeah.
have a problem, then I will let you know, okay?
Okay, okay, thank you. As my slide is my presentation is visible.
Hello, Afshin.
Yeah,
Yeah.
is my presentation visible to all of you?
Yeah. It's visible to all of us. Yeah.
Okay, thank you. So today's presentation is about the magazines that are a new family of 2D materials that I'm working on. But before going into the depth of this topic, I would start with the words of Niall Bohr. He says that a physicist is just an atom's way of watching itself. So question comes in mind, what the physicists actually do? What is their job? Like we have a common knowledge that all the chemists are studying the interaction between the molecules and interconnection between them, and a biologist is studying the life in the cell. What exactly is the job of a physicist? The answer could be very simple, that they study the physics. But then it comes in the mind, what does physics is? So according to the Wikipedia, more reliable source, and trust me, it's reliable. So they say the study of the matter and its motion through space and time is regarded as the physics, science of physics. But I have a problem with this answer, because studying physics is just not the studying of the matter. So as we know that in 2018, the Nobel Prize was awarded to the advancement in the physics of the light. And physics and the light doesn't include any mass, so it excluded into the matter. So let us take this into the account and tweak the definition of the Wikipedia by modifying it, that the physics is the science of the study of how things move through space and time. This seems better, but still this is not the perfect. The problems come with the quantum mechanics. The quantum mechanics says that we have accurate knowledge of what we send into a physical process. This is our physical process and what we measure at the end. But what happens in between this physical process, we don't have any information about it. So it is poorly defined. We have a clear information of sending in and measuring at the end. So keeping this into the account of our definition, we modify it that physics is the science of predicting how things will be and how they look when they get there. So in short, a physicist is one who predicts the future, and there are many types of the physicists: the high energy, the photonics, the gravity, the electromagnetic shielding, and thermodynamics, and so on and so on. And this red area is my research field. And to any kind of the physicists, they lie in the two categories. One are the theoreticians that predict how they come with the idea how they predict the future, and they are then the experimentalists that keep in line with the theoreticians, and they run and test the predictions made by the theoretically and then validate it, and align the second area, this experimentalists. So the process is very simple. What happens is a theoretician observes something and then they predict that this should happen like this way. These predictions come to the experimentalists. They go into the lab. They work out and they test it. If the predictions pass the test, then they become the theory and the process continues. But if they fail, then again the theoreticians think over it and make new predictions, and the whole process goes on. So generally it comes in our mind that where do these physicists work? So these physicists, a traditional physicist is supposed to be a university professor, or it can be a PhD scholar. This is the most common career thought about the physicist. But the AIP statistical research showed that out of 7 graduates, only 1 is there to finish his PhD. And so the rest of all these are either in the management, in other posts, or in STM post, or not like the traditional physicists, they are in the employment in the industrial area. So out of all the degree holders, only 14% are the traditional physicists. So moving to my inspirations, the 3 Nobel laureates, the women that excel in the physics and prove themselves to the world that they can do the house chores, as well as they can do best in the field of the science as well. So this is my research, the presentation topic, the Max and the magazines, the new 2D materials. So magazines are actually extracted from the max phases. What are the max phases? Max phases are some ceramic materials invented back in or discovered back in 1996, and more than 70 members of this family has been diagnosed, and these are the bulk materials. But when this A, like these blue dots, are removed out from these phases, these turn into the magazines, the 2D layered material that can be seen out at the bottom. The layered materials can be seen out there. And with the general formula of this, where TX are some terminations that can be oxygen, hydroxyl, or fullerene. So this was the wide known and most abundant known family of 2D materials. Up till now, hundreds of these are theoretically protected, and dozens of these have been prepared in the lab and tested for different applications. So what are these magazines? I want to describe about this. You can see this is and what makes it different from other 2D materials, why it's in use and why it is widely used in new applications now. So you can see after the graphene is now the magazines are emerging out. You can see this is a typical structure of a magazine. These golden spheres are the metal atoms, and these black dots are either carbon or nitrogen, and these are the surface termination. These are few atoms 6, like any other layered material. But what make it different from other 2D material is like this conductive core. This is a metal at the center, which is a metallic. Many 2D materials are semiconductor. The mighty graphene that is praised by everyone as a semiconductor with a 0 band gap, but these and with low charge carriers. And most of the magazines are metallic in nature, having high density of states at the Fermi level and high charge carrier concentration. But when you look at it over this, you can see that there is a transition metal oxide or hydroxide at the surface. So this is, you can imagine a material with a high surface area and with a redox active surface, which is a transition metal oxide or a hydroxide-like surface. So this you can see that now you have a material with the metallic core, and you have a material that have its properties like a redox. You can attach the terminations over it that can affect properties lethally. So and moreover, it comes in 3 flavors: the 2,1 flavors, the 3,2 flavors, and the 4,3 flavor. So it has found an application in almost every field of life. So you can see that from the energy storage to the environment, electronics, catalysis, in every field of life, you can see it has found its application. These magazines, how these magazines can be synthesized? These magazines can be synthesized by the wet chemical etching. And why we have used this wet chemical etching? Because you can see these X bonds and MA bonds. These MA bonds are purely metallic in nature. So it's very difficult to etch them out via physical means. So what we need to do it, we etch it with the wet chemical etching. What we do is we dump this into the acid and leave it for the stirring, and the multi-layer magazines are produced. And if you look at their physical appearance, that doesn't differ much. But when you look at the SEM images, you can see the difference between the matte and the magazine. The sheets are swollen up, the bezel planes are open, and at the higher resolution TEM image, you can see that this A is the A element is selectively etched out of it. So after the etching, it can be delaminated further to open up the spaces between these sheets for different applications like in energy storage and sensors and many other. Uh, Parameters that affect the quality of the magazine are the max, what max we have chosen for our synthesis of the magazine, because whenever we follow a standard protocol and we result up in something different from that, the standard protocol, it is like that our max is not that of best quality. So, and the type of HF, the pure HF, we have used either the pure HF or in situ HF or the max assets. That depends upon the swollen up of the or separation of the sheets and also the creation of the defects. And the other important parameters are the etching condition, the concentration, the time, and the temperature, because if you leave it for a greater time and the acid, that would create the defects. All these parameters affects the morphology, surface chemistry, and defect density, and that would rather have a lethal effect on these properties, the chemical, mechanical, electrical, and optical properties to be used in different applications. So before synthesis, it is very important to keep the application in mind and then follow the route for the synthesis of these magazine material. This is the reported magazine to date. As I have earlier said, that N can run from 1 to 3, but and recently 2020 in ACS Nano, there is a double metal magazine has been reported in which N is equals to 4 for the single metal, and actually runs from 1 to 3, but for the double metal, it can move to 4 as well. So I have discussed the synthesis with the HF. Now it's my responsibility to tell you about the danger of the HF, because hydrofluoric acid as with the hydrogen and fluorine bonds, and it can cause the bonds. The usual acid burn is when these yellow hydrogen ions can be corrosive to the skin like any other acid. But what is very important is these fluoride ions, these green ions. These penetrates deep down into your skin, and they can enter into your blood vessels and can cause the multiple organ injuries. So it is very important that if there is exposure to this HF, you must rush to the doctor. So because these fluoride ions can be lethal and can be fatal. So the higher concentration of HF is immediately painful. It causes your skin to burn, and you have pain inside your muscles, and because the bone, it reaches out to the bone as well. The lower concentration of HF may not be the painful, at least for 24 hours, but then it has the effect because it reaches out, it penetrates down your epidermal skin and reaches out to your muscles and bones and artery, and led to the multi-organ failure. So if by accident or by any case you come across the HF, you should wash immediately, flush out a lot of water, plenty of water over your skin, and apply the calcium gluconate cream in the case of the skin, or a liquid in case of the eyes, and take the exposed person to even if because inhalation of the fumes of this acid is also lethal. You have to be very careful. So before synthesizing these magazine materials, be very for the HF handling. Be protective, use the plastic gloves, use your special mask and for inhaling the air, and have the special equipment for the synthesis of these materials. So coming towards the magazines and my work over the magazines, we have synthesized, because if I go to the previous slide in which we have discussed this magazine, you can see this outer bar. In this outer bar, this shows that 70% of the work has been done over TI3C2TX. Other flavors of the magazines are still under consideration, are still unexplored. So I am working on the other flavors, that is the V2C. And we have intercalated this V2C with some MnO2 particles for their use in energy storage devices. And from the XRD, we can see that we have got some very well etched and optimized the etching process. And then we have intercalated with some different weightages of the MnO2 and find out the best weightage for our use. And from the CV run, you can see that the V2C has a capacitance of 203 farad per gram. And when we intercalated it with MnO2, this has increased up to 552 farad per gram, this which is remarkable achievement, and it is the highest reported yet. And this magazine flavor is also is a stable flavor. We have check stability and up to the 5,000 cycle, this routine electrochemical capacitance of 96.4%. And then the DFT studies are used to validate our studies. First, we stabilize the structure with two schemes. One is the adsorption of the atom, and other is the adsorption at the surface sites. The adsorption at the replacement sites of the vanadium results into the higher energy of formation, and it does not favor our studies. And the adsorption at the other levels at the termination site is favorable, and then we have produced this 4x4x1 cell that results in, and we have calculated our a calculation for the non-spin polarized, and it's still the density of the states has highly increased when we have intercalated these MnO2 particles into the V2CF. And from the elemental analysis, we can see that the less sites are provided by these Mn atoms, but these are in the conduction band region. So they have proved it contributed to the total density of the state of the material. And this is the energy band structure of the MnO2 V2C intercalated magazine sheets, and it shows the metallic behavior of the V2 sheets. And this is our another work on the magazine materials. That is we have worked on the Ti3 SiC2 is the titanium carbide magazine, where we have deliberately kept a small amount of SiC in it to check the coexistence of the magnetic phases. Because we can see that the Ti3C2 shows a magnetic behavior, while SiC is shows some anti-ferromagnetic behavior, so a diamagnetic behavior. So this is a study that has been recently published by our group, and then I'd like to discuss another research project, that is the laser-assisted fabrication of nanostructured substrate supported electrodes for the highly active supercapacitors. This is we have taken some non-conductive PI sheet and then reduced it with several laser irradiations that will result into this this graphene-like structure. The honeycomb structure can be seen. These FMMH, see that the smooth surface of the PI is now converted into the rough surface, and we have checked it for the electrochemical energy storage devices, and we have achieved a great capacitance for this device too over different scan rates, and we have checked it for different electrolyte as well. And at the end, I would like to acknowledge my 2D material group in which I am working. I'm highly thankful to my supervisor, and then I'm thankful to Professor D.G. Akanwande from the University of Texas, with whom I'm working with over these energy storage devices, and then to the Professor Dr. Salim Ayaz from the Czech Republic, who has helped us in the DFT studies of these materials. And this is a picture from when I was an exchange student at the University of Hamburg for some research process. At the end, I would also like to thank the funding agencies, the USAID and HEC, for providing me the funds and opportunity to carry out this research. Thank you very much, and the hall is open for the questions.
Thank you so much.
I have
completed my
time.
Yeah, it's fine, and it's a very good and excellent topic that you're discussing today. If anyone have any question, kindly ask from Abshin now, or either with the help of chat, you can ask your concern or your question from her. Abshin, again, thank you so much, and you really did your presentation within a specific time span, and I really appreciate your effort and your work as well. So good wishes for your future.
Thank you, ma'am.
Okay, so can anyone tell me who will be the next speaker? Because I don't know who will be the next speaker then. Malika.
Dr. Gulnaz, in our schedule, Dr. Gulnaz is.
Yeah, in a schedule, I know Dr. Gulnaz, but I don't know that the schedule might be they are just going to change it now.
Yeah.
It's depend on the availability of the presenter. Now, who is available at the moment? That I'm just going to announce a topic, a name. Hello. Hello, or either Dr. Asghari Maqsood is ready to present now. Malika Rani. Hello. Can you hear me, please? Now, who is ready for the next presentation?
I can present some of my other work if there is no one. So I can, or I can forward the.
Afshin, probably there'll be someone, but actually it's depend on Malika Rani that she knows that who is available now.
Yeah.
I'm just waiting for her. Is there anyone from the organizing committee who guide us that who will be the next speaker?
Yeah, I'm actually here. I'm trying to reach her.
Yeah.
Just let me get some update from her.
Yeah. Afshin, you have another presentation for tomorrow?
No, I don't have any presentation for tomorrow, but as I have skipped some of the discussion, my presentation, because I was the time was limited, so I have something to discuss with. If there's a time that I can discuss why there is a need of development of the new materials.
So I just looking towards the organizing committee. What they decided now?
Yeah, sure.
I'm just waiting. Okay, if they give me a green signal, then it's okay. Otherwise, I would like to continue. Someone is just going to join us. I don't know. It's, yes, we are praying for you that you successfully complete your PhD and then you just establish a women research group that especially the mid-career women or the new upcoming researchers that are sitting together and you're collaborating your work with the rest of the women. And it might be possible that we should be definitely done something for the future of Pakistan.
Thank you, ma'am, for your words that mean a lot, and hopefully we'll
actually I'm working on the working group of women in physics in Pakistan. So I'm interested to collect these type of women who are especially doing their PhD, or they are just going to complete their PhD. If we have some strong collaboration among the universities or among the females, so we can change a lot of things in this country.
Yeah, ma'am, sure. Yeah. And your efforts are appreciated because the women are there to take care of the other women. That's the way how the societies progress and grow out. Because leaving the women at home and letting them only to do their house chores is not how the developed nations progress. They keep their women side by side, and this is how the societies develop.
So I'm interested that why not women take a step to move toward the applied physics? Because we have a lot of gap between the industry as well as in the academia. If we are just going to short this gap, it might be possible that one day in Pakistan the people appreciate your work.
This project is about to develop the prototypes as well. We have the plan to develop our prototypes of these hybrid materials because they are super energy storage, because there is a energy gap in our country because there is a mismatch between the demand and the supply. So we have a plan to develop the prototypes for these energy storage devices, and then we will definitely have some industrial link to commercialize our product, but these are in initial stage at this time.
So there is a question for you that as we belong to 2D material group and our work is on TI3C2 and 2D material, we need to know more about it. So this is a question for you from Sonia Rafiq. Actually, this is a question for you.
Yeah. This question is that they want to know about more about 2D materials. So about this specific
group, group of material.
The magazines. These magazines are the 2D materials that composed of the metal carbides. Actually, the metal carbides are, if I can share my screen and show them the point where I have
no, we have time because you're waiting for the next speaker, so you have time to explain this thing.
Thank you. So I would like to share this one slide and look. So these are the magazine materials, and we can see that these are derived from these max phases. And from this figure, you can see that, if I can take this highlighter, okay. And you can see these phases are A, B, C, and C. These are the different flavors of the max phases, where M is some early transition metal, A is an element from group 13 or 14, where X is either these are the carbides or nitrides or carbonitrides. So, and these blue dots in between these 2D layers are these A elements. So removing of these A elements out of these 3D materials, you can turn up to these 2D materials. And like I have discussed that these 2D materials come up with some surface terminations that can be oxygen, hydroxyl, fluorines, and many more. So these 2D materials are the largest family of the 2D magazines are the largest family of the 2D materials discovered up till now, because the first max material was discovered back in 1996, and magazines only have a decade. They are discovered back in 2011 by Professor Yuri Gogotsi and Draxel Philadelphia, USA. So if you can see the color contrast here.
Hello, Assalamu alaikum.
Yeah.
Hello.
Yes, ma'am.
Yeah, Malika, we are waiting for you.
जी,
Will be the
ma'am.
next speaker.
Oh, sorry, ma'am. Actually, I have some problem with internet, so I could not connect. Ma'am, I have connected with Madam Asli Maksood. She is still busy in meeting, so we
Yeah.
should call the next speaker. And I have just talked to Madam Gulnaz as well. She said she will be there after a few minutes. So we should
Okay, so
call. Yes, we should call Meher. She is
उसे
ready.
कैसे कहूँ?
Yeah, Meher is
Oh.
ready from Korea. She will deliver
Hello,
her
Malika.
lecture.
I
Yes.
am back, madam.
Oh, thank
Okay,
you,
okay.
ma'am.
It's a good news for all of you because we are waiting for you, Madam Aswari.
Yeah.
All are
Okay,
waiting
what
for you.
should I do? I was with the vice chancellor. Excuse
Okay.
करके आई हूँ कि भाई this is more important for me. Okay, thank
Thank
you
you, ma'am.
everybody.
Thank you, ma'am. Thank you.
Okay.
So there is no need for introduction, especially for Dr. Asghar
किधर
Maksood.
है?
She
Okay,
got
thank you.
twice time. Yeah,
Oh,
she got twice time the pride of performance from the government of Pakistan. So Dr. Asghar Maksood will definitely share with us their journey in the field of science. So
बताएं
kindly,
कौन?
Dr.
ये
Asghar
वो
Maksood.
देखना
Yeah,
चाहते हैं.
yeah.
Ma'am, kindly
Okay.
introduce detailed
Okay.
introduction of yourself because our students don't know about you. So we
Oh,
want
all
detailed
right.
introduction of you. Yes,
Okay,
ma'am.
I
And
will
you
give
just
my. I will
and you
give
just share
my.
your journey in the field of physics, ma'am.
Okay. So
Thank you,
I
ma'am.
will say something at the end. कहाँ पे है? हो गया ना? किधर है? जल्दी करें. ये तो डिफॉल्ट है. पहले. Okay. So first I will talk about women physicists of Pakistan in teaching and research. Now, in the morning, we had very good introduction. Thank you, Malika Rani and her team who were able to arrange this conference under, because we are having very difficult circumstances. What if we have not a good connections and so on. So here I will just go that there is no problem in the number of these students for either female or male, both we are having. And what are the difficulties which we face and what at what stage. And then I will put myself how I have achieved something under what sort of difficulties if some people say yes. Okay, so first, women physicists of Pakistan and teaching and research. You see, when I say teaching and research, teaching is of course at the school level, college level and research, but here when the authorities, they give that we are doing some research, then there are certain organization, they feel that we are really doing some research. So in that case, if we look at our this map, so here Pakistan, Islamabad, and now of course according to our new map, Jammu Azad Kashmir is also part of Pakistan. So just to give you this idea that we have 198 universities and universities in Islamabad 21. There are only women universities, which is 8. So just to give you some idea about Air University, this was established in 2002. We have 7-8 faculties. Now, faculty members, just look at this one, 172 and female 76. Students about 6,000. So computer science, just a comparison. But you see in mathematics, interestingly, we have a big number, 131. And mathematics, I should say, comparable. So now let me give you something, my scientific work. I won't give so much emphasis on my own scientific work. It's available on Google, and I have many students in the on the globe, thank God. So my work is on the single crystal, thermal transport properties, magnetic properties, high temperature superconductivity. Then once I got interested in geologically important rocks, thermal compositional properties, thin film technology, nano technology, so on. PhD supervisors, I have supervised 17 students, 5 are already working. All those students are sitting on very high seats. And MPhil about, I should say more than 100, again very active and so on. Just to give you the rest of the students, maybe in thousands and thousands students, okay? So, uh, current status in Pakistan, then I will give some idea about the teaching at universities. Then I have considered, as I said earlier, when we talk about the research, then PCST, that's Pakistan Council for Science and Technology, they simply give some idea about, or I should say they recognize the research, okay, in terms of many factors. Then fellows, Pakistan Academy of Sciences, you see, to become a fellow is a great thing, and all the ladies, they should keep their eyes looking forward to become a fellow. Some conclusions and comments. I will, in between, I will talk about myself a little bit also. So, uh, if we look at our population, is 12 million and about 51% male and 49%. I have taken this from the reference from the internet, but in the morning I listened to a talk and there the thing was that the women is 51%, male is 50. So we can say intermediate 50-50. Now, if we look at the women, how capable she is. She was Prime Minister, Speaker of the National Assembly, Leader of Opposition, Minister, Judges, General in Forces also. At present, we have Flight Lieutenant also. Okay, many women have got this chance to work at research organization, Atomic Energy Commission, universities, colleges, and hospitals. And so in the morning, we also heard a talk from Nigat. She is the Director General of one of the sub-institute of Atomic Energy Commission. So talking about women physicists, we see about 40% of the students enrolled at universities are female. Brilliant women have achieved the positions of chair, dean, vice chancellor, and director general at various organizations. मेरे से करवा दें अगर बहुत जरूरी है. The number of these women is small compared to their male fellows, especially writing the number of publications, production of PhD students, winning of projects. Now, this document gives a critical study of the productive physicists of our country, and we will see this is less than 20%. Number of the fellows is very limited. And then the civil award won by the Pakistani physicists again, very, very small or limited. And even the problem is then when we go into the competition of the civil award, nobody is listening to us. Now I am at that stage, at least I can speak the things very openly. अब मुझे वो उन खतरात से मैं निकल चुकी हूँ. Somebody will come and simply fire me and this and that, but I will talk the reality so that young women can see the difficulties and how they have to put hard work to win something. This is again a great difficulty. Okay, so suggestion for improving the contribution of the Pakistani female physicists are also contained in this very short talk. Now, the status of women physics was presented by me and Fatima and Dr. Harun Saab. We have a publication also And here, this is the conference which held in 2002 in Paris. And there we presented the role of women as teacher. Okay, Asri Maksud is sitting here. I don't know where is Fatima at this moment, but she was present as usual in the morning. I have seen her, a great contributor, and also she takes a lot of interest to develop physics. Thank you, Fatima. Now, the improvement in the number of the Pakistani female physicists as teacher was observed again in another regional conference, and luckily this held at Pakistan. And over there, Fatima, as well as Anisa Kamar, and many other ladies were very pushing. Jabeen and Javed, they discussed a very interesting comparison between male and female PhD physics student from 1960 to 2014. It's many years. And it showed an increase in the number of the female students with time and suggested the creation of a new degree program. So anybody who is interested, I have this particular reference, they can read it in detail. Okay. So just to give you some idea, that is teaching at university. As I said earlier, there are 198 universities in Pakistan, including public and private universities, 8 only women universities, and I'm just giving you some idea how many universities. So Islamabad, Balochistan, this Khyber Pakhtunkhwa, Punjab, Sindh, okay. So here we have the number of the universities which is indicated over there. Now, from this figure, we can see the number of the universities in AJK, Balochistan, and Gilgit is small. There is no private university in Gilgit at present. Now here, I try to make a comparison of the female and the male teachers, and here I took some data. Of course, I took only 28 universities, just the percentage. And again, we can see that here, there is only one university, private Habib, which has got only female faculty. In all other universities, we can see the males are in dominant compared to our female faculty. Okay, so these are the number of the name of the universities and the information which I have put in the previous graph. So interesting to note that the 3 universities, namely Lahore University of Management and Sciences, University of Science and Technology, Bannu, and University of Swat have 100% male faculty, while Habib University has, and especially you see Lahore University of Management and Sciences, it's in Lahore. I was expecting many female faculty over there. Okay. Then I just looked at the productive physicists of Pakistan. Okay, so a little bit of history. This was established in 1961 as the National Science Council under the Ministry of Education and Scientific Research. The charter was revised in 1984 and renamed as the Pakistan Council for Science and Technology. It was designated as the Secretariat of National Commission for Science and Technology, and the Minister for S&T was made the President of the Council. At this moment, I have no idea whether Mr. Fawad Chaudhry is the President of that Council or not. Now, the reason is, again, PCS is facing a lot of problems. Okay, I'm not mentioning the problem is at this moment, but the leading physicists, even the male and the female, they know this problem already. Anyway, they have published 7 directories on the subject productive scientists of Pakistan, as these directories evaluate the lifetime achievements of productive scientists of Pakistan employed in private, public sector, colleges, R&D, that's mean research and technology development and university. So to assess the quantity and quality of research and its impact, various research related parameters like the authorship of research papers, articles in international reputed journals, supervision of PhD students, and winning of international national grants and registration of the national international patent are considered. It is evident from the data shown in the next figure that about 10% of women physicists contributed as productive scientists up to 2013. And I will also put the data of 17 here. So just look at this one. This is just the total number, male and female. And then for 2017, which is the last production, I should say, from PCSD, again, if I compare the data, the only thing is the number is almost double, but there is no difference between the production of the female physicist. So again, we can see that we have the same standing. Now, if I look at the Fellows Pakistan Academy of Sciences, so this was established in 1953. Only scientists of the highest merit who have made outstanding contribution to the advancement of scientific knowledge are elected as fellows. The academy is generally supported and consulted in all matters related to scientific education, research and development by the Pakistan Higher Education Commission and government. So this is a very important role of Pakistan Academy of Sciences. Now, the academy also provides travel grants to fellows for participation in conferences, workshops and meetings abroad, gold medals and awards to Pakistani scientists who have made original research contribution in various fields of science and technology are given. So I just checked on that data. Now, interestingly, you will see, Angie, interestingly, you will see, क्या हुआ? हाँ जी, कोई मसला है? So fellow, हाँ जी, okay. Okay, I continue. So this is the total number of the fellows and the total number and male physicists and then female physicists. Similarly, I made the comparison of the PASS in foundation. So over there, we have, and from 95 to 2002, I took the data, and it is noticed that during this period, 33 medals were awarded. Only 2 women received this medal. One of them was a physicist and another was a chemist. And similar trends are also evident in the case of the civil awards. If I look at this information, so you will see the difficulties over there. Okay. Now, some analysis. So we can see the number of, if we look at now where the problem is, the number of the female students are almost equal. I mean, 30 to 40% in these days, and in some cases, you know, females are more compared to the male student. They do very well. So the problem is that families, I mean, girls are doing very well. So the problem is that when they join the profession and start their families, that is the time where we have to do some sort of a development. So families and profession. Now, I just surveyed from my female faculty, so they had some sort of the observation. I mean, they gave me a number of the reasons, so I have put only these. Families are overoccupied due to family and demanding profession, mentally and physical. No rules support females to excel in physics and research due to rigidity in policies and behavior of administration. Now, administration can say we have a same behavior for male and female. I think the problem is we have to look after families and the profession. So I think this may not be true. In teaching, their workload is too heavy and non-supported. Again, if I look at this one, so every assistant professor has to take 3 courses, whether you are a male or female. So I don't know why ladies say that I have a heavy load. And again, I think the problem is the families and their young children, especially for married women. Another thing which I heard was having kids are given early time classes and duties and late hour lectures as well, even though by knowing their circumstance. So sometimes they also blame, I should say, or I have written because they pointed out that there is some sort of a emotional harassment to make women engage and disturb mentally, so they become unable to compete the males in research and other areas due to which their promotions are suffered. Here, I can only mention my personal view. I join, well, I will tell this thing in my next title today. But you know, sometime what happens, we have some emotional problem at home. We go to the institute, and you know, when our colleagues are talking to us, we ladies feel that they should have some sort of hamdardi for me. But sometimes, you know, they are not aware with my problems. Okay, so sometimes we cannot blame our emotional harassment which we people sometimes feel. Anyway, so these were the points which I have put in front of people. Okay, so if we do further analysis, then again these I have taken from the survey. They ladies feel that grouping in departments to make them realize that their contribution is nothing, although all the efforts and duty performed by them are up to mark. Events and duties are fixed on off time. So here I can now put my own thing. Of course, I was never a social person. You know what it means that I was not able to attend many events. The reason was I was very confined person. I did my work, finished, and I go home, and then I have to just look after my family. Of course, this uh, was sent to me from my daughter when I completed 45 years of teaching. So she said, these are the hurdle, Mama. Maybe you can have some sort of a comparison. And of course, I have given you my own picture. That's mean I'm working for my PhD degree. My baby is very small and sitting on my back. See, I was working in my laboratory with this young boy. All right. So, conclusion, I should say, same. We cannot have a blame game, okay? We can request to the government, and of course they have done many things. For example, now nurseries are available. In my time, these were not available. So government is also doing something, but let me give something. Now the next part will be just motivational. And of course, I am the author and I am the person. So maybe few people uh, will agree and few may not agree. Okay? Thank you very much. And now I will go to my next part. Idhar hai Baba, jaldi karo. Okay, so Okay, I think again, see, me, Askari Maksud. I like my this picture not for the reason that I am having so many medal. These these are the only ornaments which I have worn in my life. I was not able to dress up in a way a woman should do. Now again, it's a question. Okay, me, Askari Maksud. I have many duties, always busy at my institute. I am Dean, Faculty of Basic and Applied Sciences. Also, I am Dean, Faculty of Graduate Studies. And remember, I came, so I entered, I saw, and I captured something. What was that? That there was no faculty of basic sciences. So I had introduced, of course, with the help of many other people. Okay. So remember, I am very simple person. I was born in Jung, and I love my city because of the following two reasons. See, this city of love, many other things, and then city of science also. Okay, so my education, I had some primary education in Jang, Purane Pak Pada, ye vagara. Then I was sent to Ahmedabad. The reason was my father was a school teacher, then he became headmaster, and he has the feeling that a girl student mean I was also studying at very primary level, they should also get a good education. The difficulty was there was no school in my village, Chang. So I was sent to Ahmedabad, and there I did my matric and FSC. And I should say I was, to some extent, I was a hardworking person, and as I said earlier, not so social person. Now, just as a story, so let me give you something. Another story I will tell. See, I got the first position in board. Now, my villagers people, they took this picture and they gathered in front of my house and told to my father, see man, we told you don't send your daughter for education. Now her picture is in the newspaper. We are sure she has done something very bad. So just see the mentality at that time. Now girls, you are better off. At that time, girls and boys were not given equal type of food. Girls were given little inferior food compared to a boy.
And you have few
Now,
minutes, okay?
all right, I'll finish very quickly. So I got interwing scholarship for BS honors in physics, and because I had the first position, I did my BS honors from Dhaka University, Dhaka Fall occurred, and then I had a chance to work with Dr. Samar Mubarak for my MS degree. Again, I was able to win the gold medal. So with my only master degree, which is now equivalent to BS, I was able to join Islamabad University through competition. Okay, so this is the picture, 1975. I was looking, I'm looking so young at that time, and there in the laboratory. Okay, so then I won Oxford University scholarship, British Council, and worked at Clarendon Laboratory. I have shown you one picture. My baby was very young, so I had to deal with the laboratory and my family as well. Okay. Then I came back, and then I simply got another scholarship, and that was the Gothenburg University. So I got my PhD degree, and again, this is my picture at the time when I completed my PhD. Okay, so married to Maksud Ali, I have a son I've shown, and a daughter, both grown up. Now, of course, my interest was in research. So the first thing which I did was established thermal transport laboratory, thermal properties in 1982. And this was the first advanced research laboratory headed by a women scientist. Became, after going through many steps, became professor 1993, attended and presented my things in various conferences. So, of course, no, I don't say that the girls, they don't have to play, they don't have to be social, they are not allowed to wear nice dress, they are not allowed to own everything. Of course, they should do everything. I don't know why my case was so different. Why I was so crazy person, I should say, at this moment. So, see, I was always running after the physics, after finishing my family requirements are the things which I was supposed to. So I am receiving, I became fellow Pakistan Nuclear Society at Nathia Gali, just some pictures so that this can be motivational for the young students. Okay. So, of course, I produce internationally recognized research papers in international journals. This is the my research which appeared on the material science letters. So see, and then applied physics, another, and the third one, optical technology. And here we have developed a few things. The people, they can go on Google, see my publication and can find out these things. Okay. Now, this is the picture in my office. So another important thing is we should be very much organized. Okay, so books again put in some manner. Things should be nicely done. Just look at this one. Books, everything in a proper way. Allama Iqbal Open University. So all the corresponding in this file. Don't throw your things here and there. You have to care for your time, which is very important. Okay. So I was the first woman to become chair of physics in Pakistan. And of course, guys, now there are many ladies who have achieved this position. I am very happy to see this. And all the big scientists are sitting. It's a really beautiful picture. Okay. I became meritorious professor in 2005, National University of Sciences Technology. Then I joined 2008. Over there, again, I established another laboratory, well-known laboratory. That is the only laboratory in School of Chemical and Materials Engineering, Thermal Transport Laboratory. Dr. Iftikhar Gul is the head of that thing. So I received Satara Imtiaz and became fellow Pakistan Academy of Sciences. In between, of course, joined. Then I was awarded ZA Hashmi Gold Medal, Cash Award, Dean. And here again, I have established nano scale physics laboratory, have introduced undergrad, master and PhD program at this university. There was no program for basic sciences in this university. So you have to put hard work to create something new. And then the first MS student graduated from your university that was under my supervision. So I am again very happy to achieve this thing. Okay. Various awards. So associate member of ICTP, member of New York Academy of Sciences, member of Institute of Physics and Pakistan Physical, South Asian Publication Award, Gold Medal for Physical Sciences 2000 by Pakistan, Academy of Sciences, Civil Award, President Award for Pride of Performance, Best University Teacher Award, and then Gold Medal. This was from Prime Minister of Pakistan 2004. and President's Award, Azaz Fasilat. So I also give this talk in 2016 just for motivational, so we can see all these things. So President Award, Azaz Fasilat for academic distinction, then Sitara Imtiaz, and I was also decorated by the Pakistan Vacuum Society with Lifetime Achievement. And on World Science Day, जी बस खत्म हो रहा है Hashmi, and of course over 10 years. And last, so what is my, I should say, क्या था? Hard work is the key to success. Okay, so this was, I think, my goal. I still do a lot of hard work to supervise my student. Other people also do. I don't say that they are not doing, but this is for more motivational talk of women. So there is no shortcut. Hard work is the only key. Young women should be encouraged and motivated to achieve their goals. Okay, now the last point, which I should say, and I have faced in my, now the problem is, of course, we ladies in Pakistan or maybe in our region, we have some wall between ladies and our high ups. See, you apply for something, you cannot go and talk to them. At least I was never able to do so. I was a very shy person, number one, and my boundaries belonging to very conservative family from young, you are getting a top position, and still people are thinking that I have done something very bad. For that reason, my photograph is in the newspaper. Now the things have changed, but remember, again, we are having this sort of difficulties. It doesn't mean that we should not try. We have to try. This year I tried to get Hilal Imtiaz. I mean, I applied. HEC recommended my case. I don't know. It's not known to me why my case was dropped, though it should be indicated. But I'm just saying that it doesn't mean that I'm not going to apply next time. I will do. Why not? So once you lose something, it doesn't mean we don't have to try again. So all the best. Thank you very much. Questions are very welcome. Thank you.
Thank you so much, madam. Thank you for your successful journey, and hopefully all the participants are definitely enjoyed, because there are so many students, the chat are coming, and they appreciating your motivative talk.
Thank you.
I know well, because Dr. Azali Masood is not only my teacher, she's also my colleague, and we both are working together for the empowerment of women, especially in the field of physics or sciences.
Yeah.
So hopefully one day we will achieve this success, and probably if all the participants, they are sitting around us, if they are listening me, so I again motivated all of you to follow the achievement of Dr. Azari Masood, and probably you should definitely be a good researcher or a good scientist in future. Thank you so much again, madam. Yeah.
Thank you, Anisa. I know the difficulty that we were not able to get our status, but it means that we will keep on trying. We won't lose the hope.
Yeah.
You agree, Anisa, with me?
Totally, I totally agree with you, ma'am.
Okay, thank you very much. So nice.
Thank you again, madam. Thank you.
Okay,
thank you so much. So, Malika Rani, who will be the next speaker? Gulnaz? Our Gulnaz is ready now for the next talk.
Thank you very much.
Ma'am, I think Gulnaz is still missing. She is maybe she was on way to her home. So we will go to the Meher. She's here. She's from Korea. And Meher, are you here?
Meher, can you hear me, please?
Yes. Hello.
Okay.
Yes,
hello, Meher.
Yes. Hello.
Welcome
Everyone
to the
listening to me.
Yeah. Okay. Welcome to the conference, Meher. And you're from
thank you so
South
much.
Korea. Yeah. So kindly you just introduce yourself a little bit, and then because the time is very short for your presentation, first you
Okay.
introduce yourself and then your topic, and on which
Yeah.
topic today you are talking. You are just going to share it with us, okay?
Yeah, I just share my research-based topic. Surely, first I introduce myself. Firstly, I want to say Assalamu alaikum and hello to everyone who's listening to me and respected
Walaikum
teachers,
assalam.
guests, and young students who want to study more and want to get a motivation from young generation. And I am one of the one from that girls. Okay, and I'm very thankful to Ma'am Malika Rani who gave me that opportunity to introduce myself and introduce my work that I'm working in Korea, and maybe I wish it will be work more in future in our country, Pakistan. So in past, I had complete my MS in physics from. After that, I was teaching there, and I realized only the teaching by books and study by books is not enough for me and for my students. Then I decided I have to enhance my knowledge and get more knowledge. Then I decided to want to study more further and from abroad country, because unfortunately in our country there are no more resources. So I just started starting searching university and get a scholarship that is the biggest scholarship. If any students want to get that scholarship, they just apply and get that scholarship that is so good for our generations. Then I study here my project on two. I am working on two main projects. That is the semiconductor devices. As in my MS, I was doing my MS in physics, but when I came here, I totally changed my degree, that is electronic engineering. So in starting, it was difficult to me, but I didn't lose my hope and started working. So Alhamdulillah, now I am working on two projects. That is the semiconductor devices, and other one is solar energy cells. So in 1.5 years, I just work on one project, semiconductor devices. That what is the semiconductor devices? Actually, these devices will help us to work in our electronics devices like mobile phones, storage data, robotic, and any electronic gadgets which we are using. So
Meher, could you please share your
yeah, ma'am.
screen with
Yeah,
us,
I am.
okay?
Yes. Wait a minute. Uh,
There is an option of share screen. Kindly click on it.
Can you see my screen, ma'am?
No, we cannot see your screen.
No,
Let
you
me
cannot
ask.
see your screen.
Let me ask host. He will allow you this. Yeah, wait a moment, please.
Malika, is there any problem of sharing the screen?
I don't know, ma'am.
Ma'am, please wait. Actually, host is not here. He will allow us.
Okay, okay. Hello. Hello.
Yes, now it's
Well, yes,
okay.
we can see. Yes,
Yeah,
we
we
can see
can
now.
see your screen now.
Yeah, thank you so much. Thank you. So I am working on, like I said, semiconductor devices. That is based on, we can say, resisting random access memory. Why we call this, I will tell you the later. As we can know, the computer memory that is used for the storage, the data. So by using this computer memory devices, we want to enhance the memory devices and memory storage in our mobiles and laptops, etc. So I just working on the primary memory, that is the random access memory, and the read-only memory. So basically, I am working on the non-volatile behavior memories. That is why I am using that non-volatile memories, because these type of the memory store devices are very good for stability and get more and store more of the data which we want, unlimited data. So near to the unlimited, but we are focusing on, we have to introduce that chip that can store unlimited data in our electronics gadgets. So our main purpose of this project is that, and this project is basically based with the Samsung company, that is the all over the world very famous company, and it's basically it's located in the Korea, and it's also a branch of the Korea, and industry level is there. So what is the RAM? Resistive random accessory memory is the type of non-volatile resistive access memory that is used in the computing systems. And which work is used? It's the resist the dielectric solid state materials, or refer to the memory stir. Which material we are using for making a memory stir chip? That we can see, we use some metal on the top electrode and some metal oxide materials, semiconductor oxide materials we use in the middle state layer, and at the bottom we also used bottom electrode, which is metals we also use. So here we can need to focus which material is good for the memory store devices, or store the data, and which electrode good for storing data for bottom electrode and from top electrode. So there are some types of the memory star, that is, we can say metal insulator metal. Why we can say this structures MIM structure? Because if we use some metal on the top and insulator in the middle layer and another metal in the bottom layer, that's why we can say it's a MIM structure we are using for resisting switching. If we use MSM structure for making a memory star device, then we just need to change the center layer with a semiconductor oxide material. So these is all the types structure and inorganic materials. Why we are using these materials? Because it is not easily react with the atmosphere and cannot change their phase reactions. That's why we are using inorganic materials for storing the data for a long time. So actually, the RAM, how we can say, how we know that, how we can store a data? Actually, this data, this information come from our brains, from human beings' brain. How we, as we can say, if someone tell us something, we have to remember that thing. Sometimes we remember that thing for a small time, and sometimes we remember that thing for a long time. So basically, all the storage is depend upon our brain system. So further RAM is transferred into the synaptic devices. So yes, now all over the world is working on the synaptic devices to change the storage level of the devices. So mostly metal oxide based memory resistance switching is used for the synaptic behavior devices, because it is very promises candidate for the electronic synapses due to their multi-level and non-volatile data storage capability, It has a low energy consumption and simple device structure. What is snaps? As you can see, this is basically all the system with, connected to our brain. We have a neurons, we have the axon, we have post neurons, synaptic. This all connected with our human brain. Similarly, these devices also work like our brain and transfer the data from one neuron to another neuron. If as we say in our brain, if sometime it's lost their data, we can say this is a not a good device. If we can compare it with our devices, we can say if this device is not working for a long time, we can say it's not a good device. We need to improve our device structure, change the materials, and so many other changes we can need to change so we can find a good device and storage the data. A snap is a structure that permits a neuron from one to another neurons. Snaps has two terminals, that connection between the pre-neurons and post-neuron. Actually, when we activate the data from their neurons, and its axon is started to transfer the data, and it goes to the another neurons, and then we get some output. So this is the same structure with memristor and in synaptic behavior. So actually, how the data come in artificially or biologically? So as I show you, this is the biologically the data is transferred, and this is the electrically how the data is transferred. These figures show. We make a memristor devices like that, and it shows us data like that. If this behavior works for a long time, then we can say, so this device is working for a long time, and we can use this chip or device for our future electronic gadgets. As we can say now, the Samsung company is making a new mobiles, that is the Samsung 20 Ultra, which has a great storage. From basically, we work on that storage level, and they used our chips in their industries level. I wish I can do my work on Pakistan in an industry level if there has a lot of facilities and resources. And I actually work on international, published a paper on international level. That is two paper I work in 2 years, 1.5 years. The first paper, that is the memristive and synaptic characteristic that we use, that material is nitride based structure. On the substrate on the bottom electrode we use silicon. I can show only some readings and characteristic how it's work. So this is the behavior, how we choose our device system schematically and how it's work. As you can see, I cannot say this is the good device because this device doesn't show me a good uniformity as compared to this. So this device show me some uniformity. As you can see, how the current is increasing systematically and comes back, how goes from low resistance state and then come back to the high resistance state. So it show the stability and show me the correct uniformity and stability of the device. So I can say I use this device in the industrial level for making some other gadgets. So this is, if anyone wants to read this paper, it is an online paper. You can go and search and read this paper. It is very useful maybe for all the students. And this is the second paper. I just changed the materials and want to check this material is good for our devices or not. Then I make these devices and find out this material is very good for schematic devices and very good for storage data. So this is recently I done my this paper and it showed like that. So anyone can read from here. So my wish is that I want to work Pakistan on this using by these materials and data. I'm hopeful I can help the students over there, and because I thought that most of the people who just study abroad, if they're in Pakistan, there are not a lot of resources. They just started work here and serve that country. I I wish I want to serve my country. So this is the end of my presentation. If anyone asks some question, and according to my research and some uh, thing, I am here. You can ask to me.
Thank you, Meher. It's really a very impressive presentation from your side. And if anyone have any queries or any question, so they directly ask for Meher, or
Yeah,
even
sure.
through chat you can ask from her. Meher, it's really a very productive work. So when you are introducing this type of work in Pakistan, especially for Pakistani women, do you have any
Yeah,
plan?
sure, man. I want to. Yeah, I want to. I have a plan, but not in women university because most of the people are not giving. I think Pakistani fund are not giving too much to the women university because they are giving too much funds. I think to other universities that have a co-education. So, and some people are not working there, but I wish I try and introduce this work and make our own devices and own mobile in our country.
Is there any possibility that we're starting some collaborative work? Any women who are working in your field and they start collaborative work with you from Pakistan to South Korea?
Yes, ma'am. We are only in two ladies, girls here who are working on electronic engineering. All are the boys, and mostly the Koreans are working over there. We are only two girls. Maybe we collaborate, inshallah, and we will enhance and increase this knowledge to everyone, to our students in Pakistan.
So Meher, again, thanks for your nice presentation, and I really enjoy your presentations, especially the connection between the human brain as well as with the electronic gadgets. So for this conference, and wish you all the best for your future. Thank you so much.
Thank you so much, ma'am. Thank you.
So who will be the next speaker?
Thank you, Meher. Very nice talk. And here, can you hear? Dr. Gulnaz, are you here? Dr. Gulnaz, can you hear me? Yes, she
Ma'am, I'm
cannot.
here.
Yes, you
Yes,
are
I'm
here.
waiting for
Okay,
you
thank
for
you.
my
Okay,
turn.
good. That's good.
So welcome Gulnaz to the conference, and you have a time of 30 minutes. Try first to introduce yourself and then your topic as well. Kindly share the screen.
Actually, we skip the lunch time and tea time, so that's why we have completed our speakers. She is our last speaker.
Gulnaz is the last
So we
speaker?
have, yeah, she is our
So,
last speaker. Actually, we skip the time of tea and
no,
lunch,
no.
so we did
What
not
about
offer the
the
lunch time.
what
Yes,
about the Maria from the Republic of
she will come tomorrow.
the from the church? Okay.
She will
So this
come
is the
tomorrow morning. Yeah, she
so
is the
Gulnaz
last
will
one.
she's the last one. Okay, okay,
Yes, ma'am.
Gulnaz.
Yes, ma'am. Actually, we skip
Kindly.
the yes, we skip the lunch and tea time. That's why we are completing earlier.
So I think there is no need for skipping them, because when you're just going to mute your mic or just mute your camera, you can do your lunch as well as whatever you want to eat.
Yes, yes,
Yeah,
everyone.
that's the reason. Yeah. So Gulnaz, kindly share.
Are you hearing me, ma'am?
Yes, we are
Do you
hearing
hear?
you. Okay. Kindly share your
Yeah,
screen.
some little. Yes, I'm trying to share.
Can you share your screen?
Yes, I'm trying, but I don't know why it's not getting.
Okay, let me request host. He will allow you.
Actually, the sharing screen that is dummy for me from your side.
Malika Rani is going to request to the
Yes, we will
organizer
allow you
by
to share the
yeah,
screen. Yes, wait a
yeah.
moment, please.
Excuse me, ma'am.
Yes, we are hear you, but this screen is not yet shared.
Yes, still I'm not getting. That is not allowed to me still.
Dr. Gulnaz, can you share your presentation with me?
Sorry, doctor, I cannot. The sharing screen that is not allowed from your side.
No, can
Please.
you email me your presentations? I can share. Hello. Ji, Dr. Gulnaz. Dr. Gulnaz, I have asked a host, he is coming and he will allow you to share the screen. Please wait few minutes. Dr. Gulnaz, can you hear me?
Dr. Gulnaz? Hello.
I think she left. She has some problem with internet.
Then Malika, what is your next program?
There is no next speaker. I think she will come again. We should wait for her a few minutes. I think she has lost net.
Okay, so from the audience, there is some question about the certificate that I would like just to share it with you, that they are say that if we are attending the conference, around about 50 participants are there, and they're asking about the certificate. So
Yes,
what
ma'am.
will
We
be the
will
strategy?
provide. Yes, ma'am. We will provide digital certificates.
So how is it possible that you are providing the digital certificates if you don't have the email addresses of all these participants?
Many participants are from our university, and some are from others. They can claim, and we have the record of all the participants, so we will distribute
Tomorrow.
them according to their. Yes, we
Tomorrow
tomorrow.
kindly yeah.
Dr. Anisa?
We
Tomorrow
get the
kindly.
we will
Yeah,
get
yeah,
the
Gulnaz.
registrations. Yes, Gulnaz is here.
Thank
Yes,
God I am
Gulnaz.
back.
No, yes. Now you can
I'm sorry
share
I
your
got my
screen.
internet problem.
Yes, we
I'm really sorry.
understand. We understand. Can you
जी,
share your screen now? Dr. Gulnaz, can you share your screen now? It's allowed.
I think she has an internet problem.
I have emailed to you my presentation.
No, you can share your screen by yourself. No issue. We allowed you.
Gulnaz, they allowed you kindly share your
Active.
screen. Yeah, there is an option. There is an option of share screen. Click on it.
I can see, but it's not active on
No,
my
it's
side.
active. No, it's active. You can share. We have allowed.
Malika, if she's interested to send her presentation to you, just allow her.
Okay, let me see if she has sent me. Okay, I have received
I'm
his
really sorry. It's
presentation.
not
No, I
active
have
on my
received your
side. The
presentations.
share screen is not active on my side.
You need to refresh your Zoom.
I just refresh it.
Okay, let me check.
I have emailed
I
to
am
you.
opening your I am opening your PPT. Don't worry. I will
I
share.
have sent you.
Okay. Gulnaz, can you see your presentation?
Yes.
Okay, done.
Yes. Alhamdulillah, I have got.
Okay, good.
Yes, I can see.
Please continue.
Okay. Should I start?
Yes, please.
Yeah.
Women in Pakistan that is being organized by the Women University Multan. Do you hear me?
Yes, we can hear you.
Okay. And first of all, I would like to extend my gratitude to Vice Chancellor, Women University Multan, and Dr. Malika Rani for providing me an opportunity to share some of my research findings with the women in physics. I also pay my salam and good afternoon to Honorable Patron-in-Chief, Professor Dr. Uzma Qureshi, and Chief Guest, Federal Minister of Science and Technology, Mr. Chaudhry Fawad Hussain, and all our respected speakers and audience. This is Gulnaz, working as an assistant professor in the Department of Physics, the Islamic University of Bahawalpur. Pakistan since 2007. But actually, at that time, I was appointed as a lecturer. And after my PhD in 2017, I was promoted to assistant professor. Today, I would like to share, first of all, some of my everyday feelings and about my personal, and then I will share about my PhD findings with you. Although, Alhamdulillah, now I'm running many PhD and MPhil students. Currently, I have 4 PhD students and 5 MPhil students in the field of nanotechnology. In 2013, I was awarded FDP Foreign PhD scholarship by my university, and I moved to Malaysia, University Technology Malaysia, in the state of Johor for my PhD studies. I spent 3 years over there, and I did work in the field of nanotechnology. I worked on nanomaterials. The topic of my PhD thesis, that is also here you can see the synthesis and characterization of gold and cuprous oxide coated gold nanostructures. This, of course, the PhD work for every person that is too much extended. But here I would like to share some portion of my PhD research work. Initially, I was indebted to discuss the work on the synthesis and characterization of gold nanostructures, but later I thought I should work my recent publication on core shell nanostructures, gold and cuprous oxide coated gold metal semiconductor core shell nanostructures. Here you can see the TEM image. And on the right hand side in photograph, you can see when I was graduated as PhD, and I am at the gate of my university, University Technology Malaysia. I would like to share some of, if you see the promoting physics among women in Pakistan, the title of this research, this conference, then I would like to share about my life, how I got educated and my family promoted me. Actually, I belong to the family. If I moved to 20 years back, then really in my family, the girls were never allowed to study, especially science, and to study in co-education. So Alhamdulillah, I am very much thankful to Allah Rabbul Izzat, and I am proud of my father. He allowed me all the time, encouraged me to study higher. And one event I would like to share with you. Once I was with my father to a family home, and a lady, my father cousin, she asked my father, why you sent your daughter to co-education? So really I feel love for my father. He just smiled and look at me proudly. So that's I wanted to share that I belong to the family, never allowed the girls to study science and especially co-education. So I have the honor that I have studied, I got higher education, Alhamdulillah. So today I'm going to discuss some of my research finding from my PhD studies. Excuse me, how can I move the slide? Please move to second slide.
Malika, kindly move toward the second slide. Hello.
You cannot move by yourself. You will ask me. I will turn second slide. Not
Now,
okay?
now she's requesting to you to change the slide.
Okay.
Okay, I will remind. Okay, the second slide. Actually, I worked in the first part of my PhD studies, I worked on plasmonic gold nanostructures. Why we call gold nanostructures as plasmonic? Actually, the idea comes from the surface plasmon resonance. I think I should define the surface plasmon resonance. That is actually the collective oscillation of surface electrons. Sometimes we call the outermost valence electron also as surface electrons, oscillating against the restoring force of positive nuclei when the material is exposed to light of certain suitable frequency. This phenomena, this surface plasmon resonance phenomena, that is prominent for coinage metals, gold, silver, and copper, and that's why we call the coinage metal nanostructures as plasmonic nanostructures. So why I choose gold nanostructures? Because gold nanostructures, they are provided with unique properties, like they show surface modification, and they are provided with tunable localized surface plasmon resonance. They can be. And they show fascinating catalytic activities at the nanoscale, and they are also biocompatible. So these plasmodic nanostructures, they find applications for Raman signals to enhance the Raman signals, and biomedical applications too. So kindly move to next slide.
Malika Rani, hello. Kindly change the slide.
Yes, so if we see the growth of, yes, it's okay. The growth of plasmonic gold nanostructures, that is usually adopted by the wet chemical route. And for me, I choose seed mediated procedure and also hydrothermal method too. Usually for the synthesis of plasmonic gold nanostructures, a surfactant is required as a capping and shaping agent. And the most commonly used surfactants in the field of nanomaterials, these are quaternary ammonium cationic surfactants. In short, we abbreviate as QUARTS. So the commonly used surfactants are I have quoted some of them. The most familiarized surfactant, that is CTAC, acyl trimethyl ammonium chloride, and its chloride counterpart, CTAC. And also some of the researchers, they have used tetroxyl ammonium bromide. Only few surfactants, they are used for the synthesis of gold nanostructures. Next slide, please. So these surfactant-coated gold nanostructures we actually call as functionalized gold nanostructures. Because these organic ligands, they make these nanostructures as functionalized. Later we will see when we will move to the application side. So these functionalized gold nanostructures, they are advantages in the case they avoid agglomeration and sintering and leaching. These are certain problems associated with the unfunctionalized nanostructures, and they show bio-inertness too, and they are actually provided with increased stability and surface functionalization, because if we do not cap the gold nanostructures or other nanostructures with any compatible organic ligand, then their stability is reduced, and within short period of time they show agglomeration, and the nanostructures, there will be no more nanostructures. And but still there is concern with the toxicity of these gold nanostructures in terms of ligand type, the organic ligand, the capping agent we use, and ligand density. If we see the ligand type, then especially for in vivo applications, we need to see either the ligand is biocompatible or not. Means all type of organic ligands cannot be used, although they functionalize gold nanostructures, but they cannot be used, especially in the field of biomedical. And in terms of ligand density, as it is well reported in the literature, that CTAP surfactant that appears in the form of bilayer on the surface of gold or silver nanoparticles or nanostructures, so it increases the ligand density, especially for in vivo. So application, and also reducing its application functionality. Next slide, please. For the purpose regarding the problems associated with the ligand type and the ligand, especially ligand density for in vivo applications, I choose another quartz ligand, at my own behalf when I studied much about the family of the quartz. Then I choose, after studying the properties of various quartz ligands, I choose methyl trialuminum chloride with its chemical name Alicop 36, that is provided with 3. Here you can see the schematic illustration of the molecule of the Alicop 36 quartz ligand. We provided with 3 short hydrocarbon chains, and I used this new ligand for the first time to synthesize variously shaped gold nanostructures that I have mentioned. I prepared multifaceted gold nanoparticles. I also synthesized broad gold nanorods and got 2 publications on multifaceted gold nanoparticles. I got 1 publication in Applied Source in the materials letter, in the journal materials letter. And also I prepared gold nanowires among and triangle and cube. But remember, among all these gold nanostructures, I synthesized multifaceted gold nanoparticles while using seed-mediated procedure. And for other gold nanostructures, other shapes of gold nanostructures, I adopted single-step hydrothermal procedure. Especially when I was doing my PhD, from the literature, much literature I saw for synthesizing gold nanorods, especially they use template reduction procedure or tedious seed-mediated procedure. So for the first time, I adopted one-step method to synthesize gold nanorods. Here I have shown the time images of some of the gold nanoparticles, nanostructures I synthesized. In figure A, you can see the gold nanorods with high resolution TEM, showing the successive lattice planes on the surface of gold nanorod. Then in B, you can see cubical gold nanostructures. In C, you can see triangular shaped gold nanoparticles I synthesized. Their actual solution colors are also shown. And in D, I also got hexagonal and triangular shaped gold nanostructures. But still, there was a concern with the stability and surface functionalization of these bare gold nanostructures. So one of the problem in the literature I found that was to encapsulate these gold nanostructures with a semiconducting protective layer. Kindly turn the next slide, please. So in my case, I choose copper oxide, copper 1 oxide or cuprous oxide, Cu2O, as a semiconductor protective layer to functionalize more my gold nanostructures. So why I choose copper oxide? Because it shows absorption coefficient in the visible region. So due to high absorption coefficient, it is considered a best optical material. It is a p-type semiconductor with a band gap of 2.17 electron volt. And I synthesized variously shaped gold coated by cuprous oxide metal semiconductor core shell nanostructures. But in this slide, you see in the TEM image that I got from the literature published in 2009, and I followed his work, variously shaped metal semiconductor gold shell nanostructures. So why these metal semiconductor core shell nanostructures? The reason is this: actually, I found a lattice mismatch that was very small, of the order of 4.3% between the lattice planes of gold and cuprous oxide. So it was easy to, not very easy, but it was moderate to synthesize these variously shaped core shell nanostructures. And these core shell nanostructures, they appeared with enhanced optical and catalytic properties. And I found in the literature they can be used in the field of sensor. Next slide, please. So for the preparation of gold cuprous oxide core shell nanostructures, I used following chemicals, and the most important chemical that is actually the core material, colloidal gold. Colloidal gold in which the gold nanostructures are used as a core, and then we fabricate copper oxide or cuprous oxide as a shell on the surface of gold. So here you see the deionized water was used as a solvent. Then I use hydroxylamine, hydrogen chloride, NH2OH dot HCl as a reductant, and sodium hydroxide as an accelerator, and sodium sulfate SDS as a reducing agent, and copper chloride as a source of copper. Next slide, please. This is the schematic illustration of the synthesis of core shell gold copper oxide nanostructures. And here the solution colors actually I have drawn for the flower-like gold copper oxide core shell nanostructures. You can see different ratios of the chemicals and the total solution volume I kept for every reaction that was 10 ml, although it could be increased. Next slide, please. So these are actually the chemicals required for the synthesis of variously shaped gold copper oxide or cuprous oxide core shell nanostructures. Although I got many morphologies, but these three morphologies I fabricated in a good manner. First one is truncated octahedral core shell nanostructures. Second one is cuboctahedral core shell nanostructures, and third one is flower-like. This was very beautiful morphology I got, like gold as a core and copper oxide in the form of petals on the surface of gold. Next slide, please.
Gulnaz,
So in order
kindly
to
take care of the
synthesize,
time, okay?
okay.
Take care of the time.
Okay. So in order to synthesize variously shaped gold copper oxide core shell nanostructures, I used multifaceted gold nanoparticles, and I got flower-like morphologies. Next slide, please. These two slides, they are showing the fabrication of and characterization of the multifaceted gold nanoparticles of the average size of 47 nanometer. Next slide, please. Next slide, please. Next slide.
Malika Rani, kindly move towards the next slide. Malika.
So these are also TEM images showing variously shaped gold nanostructures I synthesized, and I use only cubicle to synthesize octahedral and cuboctahedral core shell nanostructures. Next slide, please. Next slide, please.
I think slide.
Hello, Malika. Kindly move towards the next slide.
Excuse me, ma'am. Are you hearing me?
Yeah, we can hear, but where is your slide?
Yeah, I think that Malika Rani is not present here because I call her so many times. Or might be there's some problem
Who is the
in screen
administrator?
sharing.
Problem, the internet maybe.
I think she have disconnected temporarily.
Who is disconnected temporarily? The speaker?
Miss Malika Rani, who was actually
Hear me?
screen sharing the slides.
No, my internet is okay. I think Dr. Malika Rani, she's disconnected. Do you hear me?
Yes, we can hear you. But the screen is not shared.
हाँ बहुत
I am going to call Malika Rani.
Yes, kindly call her. That what's the problem?
from Women University. Send me your slides. Who's there, please?
No, she is not responding.
Your email? Kindly send me
She
your
is
email ID.
Last, how many slides are left?
5 to 6. 5 to 6.
5 to 6. Okay.
Ms. Gulnaz, I have sent you my email ID. You can email me and I will share the content straight away.
Okay, sir.
make Gulnaz as host and she will share her slides.
Yes, ma'am. I have made her co-host, but I think she has some problems. Can't share screen.
Your screen is not active on my side. I don't know why.
Okay, you email me your slides, please.
Okay. Atif Raza?
Yeah.
Sorry, ma'am, I just lost internet connections. I am back. I will share again.
Thanks.
Gulnaz, what was the slide number, please?
Dr. Malika is speaking?
Yes.
Hang on. Alhamdulillah.
Sorry, I just lost the connection.
It's okay. The slide number is the slide number is 13. 13.
Okay. Okay. Can you see?
Yes. Yes, Alhamdulillah.
Oh, here, yes.
Slide number 13, yes.
Okay, please.
gold, copper oxide, metal semiconductor portion nanostructures. Can you move to next slide, slide number 14?
Okay.
Here I would like to show 10 images of these portion nanostructures. And although already I have shown that I prepared 3 different morphologies, truncated cuboctahedral, then truncated octahedral, then cuboctahedral, then flower-like morphologies. And how I got 3 different morphologies by using variously shaped gold nanostructures as a core material, and the ratio of deionized water to the reductant. The reductant is actually hydroxylamine hydrogen chloride that I used in my case. So here you can see in the 2 images A and B, truncated octahedral. The insert shows the schematic illustration. Inside is the cubic gold core, and outside is the cuprous oxide shell in the form of octahedra. The average particle size which I measured appeared to be 130 nanometer. And in case of cuboctahedral, I reduced, if you see, when I reduced the quantity of reductant, here in truncated octahedral, I used 0.65 ml of the reductant, but when I reduced its quantity to 0.35 ml as compared to the water, means while increasing the quantity of water, then I got cuboctahedral nanostructures, means the cuprous oxide appear in the form of cuboctahedral structure around the cubical gold core. And the particle size was increased to, it appeared to be 230 nanometer. You can also see in the TEM image too. And when I used multifaceted gold nanoparticles as a core material, then I got flower-like morphologies. In the image E and F, you can see here the cuprous oxide appears in the form of petals on the surface of gold core. And we can say this is not actually a single crystalline structure. So flower-like structure was multi-crystalline structure that I got. In the 3, if we see the surfaces, if we study the surfaces, then it is well known that octahedral structure that actually provided with 111 facets. If you use truncated octahedral structure, then you have a small portion of 100 facets too. But in case of cuboctahedral structure, we have a mixture of 100 and 111 facets. And in flower-like morphology, we take cuprous oxide petals as 111 surfaces, petals in the form of 111 surfaces on different facets of gold. Next, please. So this is the actually XRD analysis of the structures. Here you can see we find the peaks for not only for cuprous oxide but for gold too. So it means our morphologies are in the form of portion nanostructures. Next slide, please. Actually, when I used cubical gold nanoparticles as a core material, its surface plasmon peak appears at 560 nanometer. When I coat it with gold, with cuprous oxide, then we got 2 absorption peak, one at 480 nanometer and second as 716 nanometer. So we get a plasmonic peak extending to the near infrared region of light. Next, please. The same, actually, I worked on the optical properties related to the various surfaces of these core shell morphologies. And I named the samples as sample A, sample B, and sample C2. So this work is in detail. The detailed work can be found in my publication in the Chinese Journal of Physics, volume number 59, published in 2019. So due to shortage of time, just I will discuss that even when I changed the ratio of deionized water to reductant, hydroxylamine hydrogen chloride, and then I also tuned the morphology while changing the ratio of the reductant to sodium hydroxide 2 and found a bathochromatic shift in the absorption peak of these partial nanostructures. Next slide, please. This is also again the optical properties being shared and flower-like morphology you see for all, in case of Cubopterhedra, you see only one absorption peak appearing, wide and extending to the near infrared region at 817 nanometer. But in case of flower-like, we got again two absorption peak, one in the visible region and second also extending to the near infrared region of light. Next slide, please. Then I studied their surface-related properties, means photoluminescence, behavior of these partial nanostructures, and photocatalytic behavior. And as we know from the literature, we also know that there is correlation between photocatalytic and photoluminescence properties in terms of their surfaces. As we know that it is well reported in the literature that 111 surface that is photocatalytically more active as compared to 100 surface. So I observed that with my structures, I observed that the structures with 100 surfaces which are photocatalytically less active, they showed better photoluminescence emission peak as compared to the 111 surfaces. So in this curve photoluminescence study, you can see that the peak curve that is showing almost a sharp peak as compared to the other curves. The spin curve that is for cuboctahedral structure, and cuboctahedral structure that is actually the combination of 111 and 100 faces. So its emission peak was rather sharp as compared to other structures which are provided with only 111 surfaces. Next slide, please. So we can say this for photoluminescence studied. Actually, I give support these studies with the photo decolorization of the methyl orange as a contaminated water. Methyl orange using as a contaminant in the water. Deionized water are used as a solvent. So these are the photocatalytic studies of my samples. And here we can see that these two figures are for octahedral and cuboctahedral structure. Figure A is for octahedral, figure B is for cuboctahedral structure. And after photocatalysis, I measured 89.2% decolorization, means efficiency of the methyl photocatalysis I found for octahedral structure, and 85% efficiency, photocatalytic efficiency I found for the cuboctahedral structure. Why the octahedral structure showed more photocatalytic efficiency as compared to the cuboctahedral structure? Because the octahedral structures, that is actually the combination of 111 facets, so it showed more photocatalytic efficiency as compared to cuboctahedral structure. Next slide, please. Please. Previous slide, please. Yes. And this is also figure A shows the same photocatalytic study of the flower-like partial nanostructures. Same for the photo decomposition of the methyl orange. And I used ultraviolet photo decomposition. And by using 6 watt ultraviolet lamp, and also studied, and in this case I found 88.25% decomposition. And I also studied this flower-like structure, as it is the combination of 111 facets. So I also used for visible irradiation too. And I found only 65.7%. Maybe if we further tune its morphology, we can get another structures. Next slide, please. So this is the rate equation showing first order kinetic And here the rate constant K alpha I found for octahedral, you can see it is more as compared to the flower-like and cuboctahedral. But for flower-like, we can see the value is better as compared to cuboctahedral structure. So we can see that gold copper oxide nanocrystals with more 1,1 phasors, they can serve as more efficient photocatalyst as compared to the nanostructures with 100 phasors. Next, please. So these are the conclusions. So I would like to share some of these. The second last, the photoluminescence spectra of synthesized partial nanostructures traveled at cuboctahedra with catalytically more inactive spheres. These are 100 surfaces. They showed a sharp emission peak as compared to other morphologies. But in contrast to this, these partial nanostructures, in case of photocatalysis, with more 1,1 phasors, they served as more efficient photocatalysts towards the decomposition of methyl origin as compared to the structures with more efficient photoluminescence emission peaks. So, and in the recommendation, I found that while controlling the size and shape, even composition of these core shell nanostructures, their optical cross-section, it can be optimized to tune even electrochemical activities of these semiconductors, like sensors, gas sensors, or for other applications too. In the last, thank you so much.
Thank you, Gulnaz. It's really a very impressive and good talk. And I think it's your PhD work. So if anyone is interested in this field and has some queries about or some questions, so they can ask directly or via chat. Again, thank you, Gulnaz, for your time, especially.
My pleasure, ma'am.
Yeah, anyway, there's a lot of hurdles in your presentation because of from our side. But anyway, at last you complete your presentation. Thank you again, Gulnaz.
Thank you so much.
Yeah. Thank you. So the last or the second session is going to be closed now, and hopefully today different national or as well as international speakers present a very outstanding scientific presentation. And I would just like first to thanks all these speakers who spared their time, especially for this conference. I'm really thankful to the University of Multan that they're organizing this e-conference, especially for women, because they are interested to promote physics education among the women physicists. So it's a good achievement, and inshallah, hopefully tomorrow we will start with the new enthusiasm and with the new speakers. And at the end, I request to the organizing committee that we all are sitting together and planning that how we can manage the working women group of physics in Pakistan, and or some recommendation or some sort of problems that the women normally faces during their research or during their jobs. So I just request the organizing committee if they are capable to organize a half an hour talk between the speaker as well as the participant, that it will be much more beneficial. So thank you again to the organizing, to the panelists, to the speakers, to the audience, that we all are sitting together, and today we have a very fruitful day. Thank you again. Allah Hafiz.
Thank you very much, ma'am.
Thank you, ma'am.
So is there anything from Aziz Fatma if you want to share something with the presenters or with the participants? Malika Rani? There is a problem of the certificates. The participants are continuously chatting that what will be the strategy of distributing the e-certificates among the participants, because you don't have their email addresses there. Malika, can you hear me?
Well, I think she's disconnected again. Well, anyway, we will look onto the activity logs, and definitely if there is some certificate distribution, we will look onto it, inshallah.
Inshallah. So thank you to all, and then Assalamu alaikum.